That you make the next person who enters conscious by clapping when they study.
Did I pretend to be British and start it exactly at 9? I could. Let's start because I do, and we have people also online. So thank you, everybody. We commence now the Second Arabic Natural Language Processing Conference, Arabic NLP 2024. Thank you all for being here. I'm Nizar Habash. I'm the general chair of the conference. So please, I'll leave this for a second. If you can take this information so you can actually tweet about it, let the people know, take lots of pictures. During the afternoon, we will put a QR code up with the location where you can drop all the pictures that you did for the conference, so we can share it with all the other attendees and people also who are online. All right, good. I can bring this back on later too if need be. So as some of you may know, this journey started about 10 years ago, our first of the series of which Arabic NLP, although it's the second, it's the 10th, I don't know, right? It's a series that started with a workshop on Arabic NLP where the community was much smaller, and that was in Doha, Qatar in EMNLP 2014, which was a really kind of important moment for me of like the first time ever that we had an international conference of high-level recognition happening in the Middle East. Since then, we've had other conferences and other events happening. So we're very happy to be kind of part on this of this journey. And last year, we made the decision as part of the advisory board of WNLP to change the name to a conference based on popular demand and simply based on the size and the quality of the work and the level of acceptance rate that was lower than other typical workshops, so we're a small conference. We're hoping to get bigger, but we're too big to be a workshop. And today, as you all know, we have the second Arabic NLP conference. This is our Google Scholar. We actually have a Google Scholar just for WNLP, Arabic NLP. So we're 39 index, so keep working and helping us make this look better and better. All links, by the way, of these things are available on the sigarab.org website. So this year we had about 68 submissions to the main conference. It's actually slightly lower than last year, but that's probably because we had also several other competitions during the year. My personal view is we should consolidate some of these events that are competing, and making it weaker in general. But in any case, we have a lower acceptance rate than we did previously in any of the previous events. Oh, shoot, this is supposed to be Rami's moment to talk about this. I introduced my colleague, Rami Skandar. Please, Rami, you should.
Yeah, it's all fine. Yeah, so as Nizar said, the number of submissions is less than last year, but it's not like much less. I would say like 90% or so. Okay. So it might not be like statistically significant here. The acceptance rate is lower, which is a good thing. It's a good thing for the conference, maybe not for the people, but to understand this. So we got like most of the papers were long ones, 25 with 4 short papers. For the shared tasks, we had 8. To be honest, we tried to cut some of the shared tasks. Like we were worried we cannot like host 8 shared tasks on the same day, but we ended up like being so nice. Like let's have like everyone participate in this, which is good. And for the shared tasks, we have 71 system description papers, which is like a large number actually. Very promising here. So we end up with 108 papers, and they are all in the ACL proceedings. So you can access these as of today. You want to talk about this?
Yeah, sure. Okay. Maybe about the shared task, I'm discovering more and more that for a lot of new people, it's the best entry point. It's not as competitive, to be fair, of course, and it's also exciting and kind of energetic and being part of the community. So thank you, Rami. The structure today, after we're done with this welcome speech, we will have 4 sessions organized around core technology, downstream applications 1 and 2, and multimodality. The talks were selected because of we thought it was more appropriate to them to be presented in the form of a talk. There'll be a coffee break, of course, 2 coffee breaks in the morning and the afternoon. During the lunch break, we plan to reconvene here if you want. It's not obligatory, about 1 to 1:15, just to have a SIGARAB kind of social. If you want people talking with each other, you can bring your lunch box or whatever, and there'll be, we talk about different topics and etc. We also then have an invited talk in the afternoon by our colleague Kareem Darwish about a wonderful effort that he's been leading for the last year in the community. Then we will have boasters, and this is not an Arabic mispronunciation of boosters. And it's not, it's to basically proudly talk about the task that you're interested in, which is basically the shared tasks. So the leads of the shared tasks will give a 2 to 3 minute a quick summary of what they did, and then officially then we will actually convene and go to the coffee break, and then we will go adjourn, go to the coffee break, and after that there is the poster sessions, which we will all go to. So after the poster sessions, there's no need to come back here, and I encourage you all to make new friends, go out to dinner, help build the community beyond the workshop itself. So the schedule is very tight. The speakers will have 12 plus 3, which means 12 minutes to talk, 3 minutes to get questions and answers. If you don't want questions, keep talking, I suppose, until we kick you out. Someone will be sitting at the front. They will hold a little piece of paper with a number on it that tells you how many minutes until you need to stop. Okay. And we will stop you, right? Okay. And then, unfortunately, this is not my liking, and I'm sorry about this, but the online session of the posters, there's also some posters online, and I think in GatherTown, these will be happening at the same time as the actual poster. Personally, I don't think this is a good design. It wasn't my choice, but it's basically splitting the community into the virtual people and the in-person people. But that's what we have this year. All the paper, as I said, are online, and any slides and talks they provided to underline will be also online. So you're not going to miss anything. And you can always just email somebody, be friendly, and get to know a friend. Okay, so quickly about a few of the awards were decided.
Yeah, sure. So anyone is expecting to win anything today? Yeah. Okay.
Oh, come on.
Okay. That's not easy to decide, right? Yeah, sure. Yeah, so that's our best paper award, event, arguments, extraction, corpus, and modeling using BERT for Arabic.
Can you stand up?
Yeah. Yeah, so it's Ala Al-Jabari, Lina Durbis, yeah, Mustafa, Jarrar, and Muhammad Khalilia. Is that right? Okay. Do I have like rewards to?
No, so for them, well, I already sent them we're being green, so I send them the certificates, and their talk will be in the first session in the morning.
Oh, so you know already, right? Okay. Yeah, others don't, so it's fine.
It was on the email, Robbie.
Okay, for the best reviewer, and that's not easy, it's Angie Hamid.
He's not here.
Oh, okay, that's fine.
Okay. Oh, okay. So, SIGARAB and ArabicNLP are all run by volunteers, and there were all these people. So, Rami and I are here. Huda, unfortunately, couldn't come. Many of you know her, and also Nadi couldn't come. We also want to thank the wonderful Ibrahim Abu Farha, who did a fantastic job because he thought he was getting a simple task, and it became almost like running another conference on the side with the shared task. So hats off to him. Ahmed Abdul Ali and Sami Twilib were amazing in the last minutes of managing to get the publications put together. And Inji, of course, won the award, and Yasser and her were part of the scholarship and awards shares. Thanks also to the social chairs, Salam, Khalifa, Bashar Al-Hafni, and Wissam Antoun, and also the sponsorship shares. We did get a bunch of money this year, which is good, and we used it well, I hope. That's Hatem Haddad and Ahmed Zitouni. And also the social chairs, Badr, AlKhamissi, Rawan al-Matham, and Khalid Mrini, who, although only Badr was here during the event that happened on Tuesday, all of them participated in designing that event. And thanks to Waad, who of course was present but is not officially one of them. And of course, all the work really was done by the PC committee, which I cannot go through all of these names fast enough, but they were all like fantastic. I had like an army basically of ninjas basically doing things for me, for us. So we're very thankful to all of them. The shared task organizers are particularly also, I jumped through them. I should say something. They were all really like running mini conferences or mini workshops within the big system. So this is great. If some of you want to help also with running the conference in the future, let me know. We'll be happy to give you more fun to work with. So just wanted to acknowledge all of the slides will be added on the website of the conference, of course. And a special word of thank you for our sponsors this year, which are Google, Sky, Sadaya/Sky, Jarrar, مجمع الملك سلمان العالمي للغة العربية, and Lisan. And I'm actually going to stop here because I'm worried about the time. If you have any questions, I can do the SIGARAB report maybe in the social session in the afternoon, just because I'm worried about the time. So I think if you come back we'll call it the business meeting of our conference. I didn't plan it to have it that way. We have now a couple of minutes for the next speaker maybe to come up, and everybody else knows, or if you have any questions about anything related to this. Yes, You have to use your own PC. Yeah, I think the COVID experience is fading from our memory very, very quickly, and any good that came with it is also gone, unfortunately. So I don't really know actually if that's the case. Should I just? But all the talks are recorded. Yeah, all the videos have already been recorded. So the only thing that you'll be missing is me and Rami talking. But you've heard enough of that. Yeah. Okay. All right. So in the interest of timing, I think the first session chair is going to be Mustafa Jarrar. Do you want to come to the front to start introduce people basically who are going to be doing the talks, please? Oops. Yeah, it's all in one directory. So I just logistically, I put everything in one directory, and hopefully people will know the names of the files they uploaded. I wish we had a common standard for doing this. Okay, I think we're good. So.
So welcome everybody. So we will start with Osama.
Yes.
Osama Mraikhat.
Mraikhat.
Mraikhat, yeah, nice. And the paper with Hadi Mahmoud and Fadi Zaraket about AREEj. AREEj is a relationship extraction with evidence systems. Please.
Hello everyone. I'm Osama Rakan Mraikhat. I'm a data scientist at the Arab Center for Research and Policy Studies. Today, I will be presenting our work, AREEj, Arabic Relation Extraction with Evidence. I will start with some definitions. Then I will talk about the importance of this task. And finally, I will talk about our approach and its evaluations. So what is relation extraction? Relation extraction is the task of automatically identifying related entities from the text and the relation type between them. The relation type is a predefined class that the large language model tries to predict. So let's see this example. تأسس المركز العربي للأبحاث ودراسة السياسات في عام 2010 ومقره الرئيسي في الدوحة في قطر. Here we can see that the organization, the Arab Center, is related to the entity 2010, which is a date. And the relation type between them is inception. We can see that this is true because of the word تأسس. So this is what we mean by evidence. So the evidence is what we use as the humans to identify this relation. And it supports the relation. The evidence can be a word or can be a phrase. So here we can see that ومقره الرئيسي في قطر these evidence are a phrase, not a word, like تأسس. There can be many sources and many target entities in a given document. Here we can see that the Arab Center and Ad-Doha are source entities. And each source entity can have many target entities. It's a graph. So each relation consists of 6 elements or components. The source entity, the target entity, the named entities of the source and the target, and the relation type and the evidence. So why is this task important? Relation extraction is important because it enables us to build knowledge graphs. Evidence extraction or evidence in general is important because it helps us explain the predictions of our large language model, and it also improves the relation extraction task. So when we started working on this project, we wanted to find a data set that would allow us to fine-tune an open source large language model to do this task. We found the data set AREEj. This data set doesn't contain evidence. So it only contains the 5 elements. It doesn't contain 6. This data set contains 40 million relations in 18 different languages. The Arabic subset contains 2.9 million relations with 393 possible relation types. We made clusters from this Arabic subset based on the relation type and the named entities of the source and the target. We sampled from these clusters and we passed them through GPT-4 to add evidence annotations. The prompt that we used with GPT-4 included a chain of thoughts, which means using intermediate steps and giving them to GPT-4, which is in this case the evidence. So we tell GPT-4 that we use this evidence to extract these relations for some given relations. Then we give it new unseen relations to add the evidence. We also provide the number of relations in each document when we want to extract the evidence. So now we have a smaller data set with the 6 elements that we talked about, smaller than 2.9 million. We use this data set to fine-tune BERT, which is open source, to produce AR-BERT EV. AR-BERT EV, it's trained or fine-tuned to given the input sequence, which is the text with the relations, outputs the relations with the evidence. So here we can see that this source and this is the target entity, which is a number, and the relation type is population, and we know this because of بلغ تعداد سكانها in the text. So this is the evidence. So the output sequence is the relation with the evidence. And we use this special token text to separate between the text and the relations. So the large language model knows that the text ends here and the relations begin after this special token text. So now we have this open source model that is capable of extracting evidence given the text and the relations. We use it to annotate the whole 2.9 million Arabic relations. And by that, it achieves 0.82 Afwan score in evidence extraction. So we produced this new dataset called AREEj, which contains 2.9 million relations with the 6 elements we talked about. So now we fine-tune BERT again, but this time the input sequence is different. The input sequence is only the text without the relations, and the output is the same as the previous model, which contains the relations with the evidence. So the large language model tries to predict this sequence given the text. This is a larger example. This example contains many relations for the same source, Sukhoi So 11. This special token BOR means that this is the beginning of relations for a new source. If we have more sources in the text, we would have another BOR tag at the end of this sequence with a new source and new relations. So all of these targets and relation types and evidence are only for Sukhoi So 11. These are the evaluations of our model AREEj. We outperform MRebel, which is a large language model trained by the authors of ASRED-FM, the dataset that we used. Some manual evaluation was done because the testing dataset only contains 32 relation types from the 393 possible relations. So we can see that it achieves 0.72 Afwan score in relation extraction. This is just a summary of everything I talked about. So you can find it in the paper, and you can quickly remember everything we talked about today. And you can also try to use AREEj if you like to scan this QR code. And that's it. Thank you.
Very nice work. Congratulations.
Thank you.
For doing this. I was wondering, what's part of your sort of rather not too high a class score, and can you attribute to the quality of the data? Because I think that when you annotate the data, probably if you have 80% F1, you just get all the 6 types, and probably then when you train your model, it goes slightly lower. Do you think that if you were able to improve your data set quality, that the model will really go high?
Yeah, I think if we use human annotators instead of GPT-4, that might be bring the quality of the data up and make the model better. Yes.
Can you actually use the microphone because there are people who are online?
Thank you. And you compared your model with a previous one.
Yes.
And it looked like you had a much higher recall than them, but the precision was a bit lower. Do you think, do you have an explanation why is it? Is it just a method that you used, or?
I don't really have an explanation for this.
Thank you.
Thank you.
So first, if Inji is online, hello Inji, this is Sanjeev. Hi. I had a question. So the part where you use ChatGPT, right?
Yes.
Did you think about, did you try something simpler? Maybe it won't work for all the 300 something type of relations, but for many of them, could you just hack a regular expression and get the evidence? Because what I'm thinking is you should always do something like that to make sure that you can ground ChatGPT in something that you're sure of. But the thing with regular expressions is they
Yeah.
tend to be high precision, but they won't recall everything, right?
Yeah.
Yeah.
We have a solution that uses
Mhm.
regular expression, but it's not very good.
I see. Is it because the way the evidence is expressed is not easy to characterize with a regular
Yeah,
expression? or-
there's a lot of let's say wrong evidence extracting using regular expression.
I see. I see.
Yeah.
Yeah, the reason is that, like, there's a bunch of other work I remember, like, Marty Hurst and all did a bunch of things where basically she showed that a lot of information extraction can be done with regular expressions. It's just that there's a very long tail, which is why we need other things.
Yeah.
So,
Yeah.
okay. But you're saying that that here it's not, even the head is not very big.
Yeah, we had this solution before. That this is why we built this one.
Okay.
Yeah.
Correct. Thanks.
Thank you,
Thank you, Osama, right?
Osama.
Okay, thank you, Osama. So two quick questions. One is about, so the data set that you talked about a question for you, Osama. Sorry. Sorry.
Yes.
I'm always here. So the large data set that you worked with, the one, sorry, I can't remember the acronym, it was a long acronym.
SRED FM.
Right. So you guys extracted a portion of it that has to do with Arabic. Was there any particular, constraints or kind of
Yes.
lessons learned for the community if we want to work with this data for how you selected? That's number one. And number two, following up on Sanjeev, it's good to hear that you had the not so good system, but did you actually report on it in the paper?
No, I didn't, but we want to report on it in the future.
Yeah, it's always good to kind of show, at least like it's not really how bad, but how good they are, even though they're worse, right? But yeah, and the first question, if you could answer, would be good.
The first question.
Did you make any decisions that are useful for us to know about when you selected, or you looked up?
No,
Sorry.
the text wasn't the text that we passed through GPT wasn't the number of words wasn't greater than 85 because it's expensive to pass it through GPT. That's the thing. And our prompt was very big because we used chain of thoughts. Okay.
Thank you, Osama. Can you please go back to the data set, the original data set? Yeah. So I am not aware about this data set. Can you please give us more details? Is it manually created, automatically created?
No, automatically created.
What topics?
Yes.
Automatic?
Yes. From Wikipedia.
Yeah. Did you verify the quality for the annotation?
And there's mistakes, yes, because it's automatically created.
Okay. Yes,
SRED FM.
SRED. Thank you.
You know how it was automatically created? Following up this question.
They have a tool called. I will give you the name of the tool. Yes,
No, but
it's on GitHub.
But was the test set that you evaluated on human validated?
Yes.
Okay, so even though the training data may be noisy, the test is clean.
Yes. But we also verified manually the test.
Thank you.
Question, and we can start preparing for the next.
Yeah, so maybe one last question. So how do you select as examples in your prompt?
We made clusters and randomly selected from them.
So are they fixed regardless of the training sentence, or?
They are selected from the training data set. Then we sampled randomly from them based on the relation type and the named entities of the source and the target.
I see. Thanks.
Thank you.
Okay, so for the next presentation, we're going to have Muhammad ElNokrashy.
Badr AlKhamissi.
I'm
The
Badr
second
AlKhamissi.
author,
You are
yeah.
Badr
I'm
AlKhamissi.
Badr AlKhamissi, yeah.
And the title is Context-Contrastive Inference Approach to Partial Diacritization. So we are in time. So
Okay. Thank you.
You can view it directly in Google. You just double click on it, it should open.
I think the format changes. Okay.
Welcome. This presentation will cover the work, a context-contrastive approach.
Okay, sorry. I might have had.
You can pretend like
Yeah, I'm just wanting to make sure that's actually the correct version. Okay, let me actually.
You can study
But
it.
in use with that.
Yeah, yeah, how? I don't know how to use it.
I think it's like this, maybe.
Yeah, I think you did it.
Yeah, right. So now it should be fine. Let's see.
Okay.
Okay, so this is the video we uploaded to Underline, so sorry about that. I hope this is the correct version. Okay, so hi everyone, my name is Badr AlKhamissi. I'm a PhD student at EPFL. Today I'm going to be presenting our work, a context-contrastive approach to partial Arabic diacritization. This work was done in collaboration, this work was led by Mohammed ElNokrashy, who sadly couldn't be here today, and in collaboration with myself. So I know the audience here are very familiar with the problem of partial Arabic diacritization and the importance of it, but I will just give a brief motivation as to why, the motivation of diacritization for those who might not know. So in general, we know that Arabic utilizes an impure abjad writing system where long vowels are written as full letters in the word and short vowels are usually omitted. So on the table here, we're showing some examples of the diacritics we utilize in our paper. So for example, the Dhamma is the U vowel sound. Sukun indicates the absence of a vowel. Shadda is for gemination or consonant lengthening. And on the right, we have an example, which is 3 letters written using only consonants. And we can see that this word can be read in at least 2 ways. So one word is kasr, which means breakage or something broken. And the other word is kasir, or a secret, and this one is comprises of a preposition and a noun. The other one comprises of only a noun. So one thing to highlight here as well, that we only use not all diacritics, not all letters are marked, so only a few letters are used to be able to disambiguate the meaning of the text. Okay, so here in general, we know that we want to disambiguate the meaning of the difference between full diacritization and partial diacritization. So full diacritization implies that we have a mark for each vowel sound in the sentence, while partial diacritization implies that we have only some marks for some of the vowel sounds. And we know that this is usually used to aid reading and disambiguate the meaning of the text. So we know from prior literature that actually a lot of people in linguistics and psychology have studied this phenomena where highly diacritized texts are read usually slower, so it affects the speed and the accuracy. This is usually studied by monitoring the eye movement of people reading the text. So usually there's increased reading time for highly diacritized text, as opposed to partially diacritized text can actually improve the reading experience by having a better speed accuracy trade-off. And we have a long list of citations in the motivation section in the paper, so please feel free to look at it. I'll skip this for now because we have it in the end. Okay, so returning to our example in the paper we just showed, so we have the word here kasir is written in using different level of diacritics, and we can show here that we can actually annotate the same word using different ways, and each can actually be have different, is annotated depending on the level of ambiguity given the context. So some words might not need many diacritics, others might need more, but in general, it depends on the context and how easy it is to disambiguate the meaning of the text. Okay, so the motivation of the paper is now outlined. Now let's move on to the method section on how we implement this partial diacritized system. So our work basically utilizes can be able to utilize any diacritization model. So there's no need to a custom system. And the idea is we have the same model applied twice to the same, once to the sequence of text with the context. So the word you want to diacritize, like al-Qutta here, with the surrounding context, and another time without the context. And the idea here is once it's only guessing the word, like a naive guessing of what should it be here, and the other one requires the contextual information. So we call them contextual and non-contextual predictions. And with this, we implement something we call context-contrastive partial diacritization, or the CCPD algorithm. And here we basically take the contextual prediction, we compare the two predictions from the contextual and non-contextual, and if they are equal, we assume that the mark at this location is actually very easy to guess without context. So here context is not important if they're both equal, and if they're not equal, therefore the contextual information is important, so we add the diacritic to the final output. And to put it more formally, this algorithm basically has, again, the contextual and non-contextual prediction. The contextual is, we denote it by F cent, where F is the model. So it takes the word and the letters of the word with the surrounding context, where the non-contextual prediction only contains the word alone with its letters, basically. And the algorithm assigns the mark using the contextual prediction. So of course, like using the surrounding context, if it decides that this location or this letter should be marked with diacritic. Otherwise, it doesn't add anything. And we have two ways to decide what mark, whether to mark this. So we have the Mraikhat function, which is, we discussed earlier, basically the prediction disagree with each other. The other one is more soft. So it uses a prediction, it uses probabilities instead. So if the contextual prediction is higher than the non-contextual by some margin, we add a contextual prediction. Okay, so one problem with the partial diacritization is that there doesn't exist any natural benchmark or any large corpus in order to actually evaluate those systems. So we came up, so one solution is to actually gather some data sets online from and try to evaluate those benchmarks. Another way is to come up with some unsupervised performance indicators in order to evaluate our system. And for now, that's what we did. And I'm going to describe the systems now. So the first one is two very basic indicators. The first one is the selection ratio. So the selection ratio or the selection rate just counts the number of letters that are marked by our system. So we denote this as DS over D, where DS is the number of the letters that are marked, and D is all of the letters in the input text. Then we have the diacritic error rate, which is parameterized using F, the model, and D, a data set, which might contain a subset of the letters. So this is a basic diacritic error rate, but only on a subset which can be DS or DU, or the full data set. Okay, then we came up with another one, which metric, which we call reader or reader diacritic error rate. This is basically a weighted average between the contextual error rate on the marked letters and the non-contextual error rate on the non-marked letters. So I can explain the intuition this later, but for the sake of time, if you have any question, like happy to answer it after in the question session. And the idea here in intuition quickly is I assume that non-contextual predictions are easy also for humans. Okay, so another metric is the basic diacritic error rate and the partial diacritic error rate. Those are basically measuring the non-contextual error on all letters, and the partial diacritic error rate is the contextual error on only the marked letters. And all of this is described fully in the paper. Okay, so finally, we have what we call signal utilization. I'm going to skip this slide quickly because we have another more slide that makes that's easier to comprehend. And we basically say that we want to know how much information the system actually allow the people reading the text to be able to understand. So how much of the diacritized text contributes to the decrease in guessing error. And this is just the difference between the non-contextual error rate with the contextual rate. So if the contextual error rate is small, then we and is smaller than the non-contextual error rate. So we know that the contextual rate is giving better information or giving more a signal that the user can aid the reading afterwards. Okay, so for our models, we use a transformer-based model and an LSTM-based model. Transformer-based model, we implemented a variant of D2, which we introduced in the previous work. And we use also Shakkala and Shakkala, which are character-based recurrent models. So all models are used as is without any modifications or any task-specific changes. For the results, this is the table with all the indicators and all the results on all the models. I will skip this also for the sake of time, but please let me know if you have any questions. So just to give an intuition behind the metrics again, selection rate, we want to see like around 13% selected. So this indicates the natural annotation density, which have been shown by previous work. We want to see that the basic diacritic error rate and partial diacritic error rate and the reader basically have a low score, so lower is better, whereas the signal utilization have a high score, so the annotation actually gives new information to them all to the output. And here we know by applying those rules, we can see that the D2 system annotates 6.5% of the text with a basic diacritic rate of 7.1%, where the closest system matches it is by Fadi et al., which boasts a lower partial diacritic rate and but uses more characters basically to do this. So it annotates 8.9% of the characters. Here we also used, this is the one we used with the soft marking mode. Basically it shows there's a trade-off between the signal utilization and the partial diacritic error rate. So in one case, we have a low signal utilization and a very low partial diacritic error rate. But on the other hand, we have like a higher partial diacritic error rate and a higher signal utilization. So each metric actually measures something different. So it's important to basically know what you're asking and what you want to measure, and can like give information to new techniques. Okay, so we conduct a human evaluation. I'm almost ready. almost ready to finish. Okay, so we conduct a small-scale human evaluation experiment, and each participant was shown 30 sentences in sequence, each for some seconds, between 2 to 5 seconds. So many of which you actually participated in this human evaluation study. So we thank you very much for that. And the sentences are selected such that the participants are she's a third with no diacritics, a third with partial, a third with full diacritics. And after each sentence is shown, the participants score the sentence from a scale from 1 to 5. And what we show here, that the partial diacritization actually improves on the full diacritization in terms of the reader confidence of understanding the sentence. So how confident the reader is for understanding the sentence using the limited time budget they have. And the next steps we have for this project is actually want to gather a larger partial diacritization data set as a natural benchmark. We want to conduct a larger human evaluation with longer reading times and augment the method with minor training in order to improve the partial diacritization system. We have a demo online as well on Hugging Face for anyone to use. And with that, I thank you, and if I open for any questions. I want to add as well that apparently the slides were the old version, so that's why there was a problem with the time.
But Badr, you
yeah.
don't talk about that. Just
Okay.
it's good, great presentation, great work. Just a quick question about when you talk about partial diacritization, Badr. You saw we had another paper in the conference on this, looking at it from the other side of analysis, and there were a very large percentage, if I remember, in the 70% or so in partial diacritization used in news is always tanween al-fatah.
Yeah.
And it actually is not that meaningful anyway for understanding my sense. So I'm curious, when you were actually evaluating, did you count did you make a distinction between the type of diacritics, or you just looked at the diacritics as is and you didn't care? So in fact, maybe 70% of the instances you're trying to predict were about not really understanding, but just following this tradition of indicating the tanween in those cases.
Yeah, so no, we didn't. So the tanween is actually usually can be predicted by the non-contextual prediction, so without the context, and therefore it usually is not predicted in the output text. So we don't actually Most of the time, it's not needed in order to disambiguate the meaning of the text. And we did differentiate between different domains, so the news versus poetry versus so on. And I think this is room for other work because the natural annotation density is actually differs between different domains as well.
Okay, so you took the word out of context and you asked the model whether this word is ambiguous or not.
Yeah, exactly. So how easy it is to be able to predict the critics without the context.
Okay, so if you have a word like yuhaddid, so normally diacritics like shadda and dhamma are less frequent than fatha or kasra. So, and actually it's a matter of styles of some persons to always put shadda and always put tanween at the end, okay? So if you take this word, it has only one morphological analysis, so it's not ambiguous. But in many cases, people want to put the shadda and also the prompt starting sound, which is dhamma. So in some cases, people prefer in this case to put dhamma and shadda, and also in some cases we need to put the final case ending for correct understanding and pronunciation. So, but you didn't consider any of these, the style issue, the final case ending issue, right?
Yeah, so this is actually, we saw that our system is able to learn this on its own. So it's able to usually, puts the last, the case ending because it's useful in order to learn the meaning of the text in the end. And in the end, the purpose of the system is to be able to disambiguate the meaning using the lowest the critics possible.
Sorry, we are.
Okay, yeah, right. Thank you.
Just 2 minutes. Okay. So now with Salam, Khalifa, Abed Kaddoumi, Eileen Bresloya, and one Rambo. So please.
Good morning, everyone. So I'm Salam Khalifa. I'm a PhD candidate at the Department of Linguistics at Stony Brook University. And today I'll be presenting our work, picking up where the linguist left off, mapping morphology to phonology through learning the residuals. And so jumping right ahead, the task is to generate morphological representation or transcription from a given morphological analysis, aka tokenized version. So this is relatively easy for the standard or the classical. You have very few handful rules that to go from a tokenized version to the pronounced version. So an example here, you can look at the morphology here, katib. Here. Yes. So katib and then the feminine singular ending in MSA, you just, copy everything katiba, but then that's actually different in the dialects. Some dialects would delete some vowels, so katba, and in some other dialects, even more operations like katba in Egyptian. And so the goal here is given an underlying morphological representation, which I'm going to call MR, we want to generate the spoken form or what the linguists like to call the surface form. And the case study here is Egyptian Arabic because we're blessed with so much data for Egyptian Arabic. We have a lot of morphological, analyzers and resources, and we also have a great resource to provide the spoken form. And my running example here will be the word ba'ulhum in Egyptian Arabic. And so maps between those two forms actually exist, but in grammar books developed by linguists. But then once those rules, so linguists devise those rules, either rules or constraints, but we're gonna use rules in this work. It's from their knowledge of the language or the dialect and by looking at few points of data. So once we take these rules out of those books and try to apply them to real world data or corpus data, they usually, fall a little short with some exceptions and whatnot. So in our approach, we want to use those linguist rules, take them out of the books, and we want to learn how to correct the residuals from the unrecovered spoken forms or surface forms. And so to formalize this better, so we want to know how well is the coverage of the linguist rules. And then this task is very similar to a grapheme to phoneme task, not exactly the same, but very similar. So we want to see how the rules perform if we run this as a graphing to phoneme task. And then can we extend the coverage of the rules that now that we know it, and then what happens in low resource settings. So I'm just gonna run quickly through the linguist rules just to give you an example of how those rules are applied or how they look like. There are more details in the paper. So the linguist, Ellen Broslow, who's also an author in this paper, gave us a set of initial rules and told us, okay, these are the general rules for Egyptian Arabic. These are not all the rules, but mostly the general rules. So we start with the definite article, the sun, moon letter, Shamsi Qamari letter. It doesn't apply to this example, so it doesn't fire because also this is a verb. Second rule called first vowel deletion. So when you have a vowel from a proclitic and then a vowel that's from a stem or a prefix of a stem, the first vowel, the vowel of the proclitic deletes. And then, so in this case, the E deletes, the R remains. Second is epenthesis or vowel insertion. And so this is when you have a consonant of cluster, a cluster of consonants. So in this case, L, lam, and ha. And you need to break this cluster. Different dialects do this differently. In Egyptian, you usually add the vowel before the last consonant. So in this case, it's at U. And then you have the first operation, which is a deterministic way to chop the word into syllables, syllabification. And then high vowel deletion, which is usually an E. It doesn't apply here because we don't have it. Long vowel shortening. So if we have a long vowel that is not in the last two syllables, we shorten that. And then stress assignment, you can read more about what stress is and how do we assign it in the paper. But basically in this case, we added this apostrophe here. So this is the stressed syllable of the word. And then the last rule, which also doesn't fire here, is the unstressed long vowel shortening, which we don't have. This word only has one long vowel. And at the end, you have the surface form. So in linguistics, usually in the way they do it, they have a bunch of rules, they are ordered, they need to apply one after the other. Sometimes you have contradictions that will not generate the true form and so on. So it's not a perfect process, but it gets you somewhere. And so to answer our research questions, we set an experimental setup. So we have the usual pipeline, we have a train, dev, and test set to test on, but in this case, I'm reporting on dev, more specifically the unseen, the unseen entries from dev, so the OOV of dev. And then the data looks like pairs of the morphological representation of the spoken form that I've showed in the beginning, and then we have two baselines. A do-nothing baseline, which is just copy the morphological representation as is, just remove the morpheme boundaries, and that's your surface, the predicted surface or spoken form. And then a character-based neural transformer, which has been used in the graphing to phoneme tasks and the sigmorphan share task. And we apply both of those to the morphological representation to get a predicted surface form or spoken form. So these are our baselines. And then for the systems, we have two systems. The rules, so these are the 6 rules and 2 operations that we got from the linguist. We apply them directly on the morphological representation. And then the second one is transformer residual, which is applied on the rule predicted surface form. So we apply the rules to the morphological representation and we get a rules predicted surface form. We train the transformer into pairs of the predicted surface form and the true surface form, and we apply it eventually to the rule surface form to get, so this is like basically trying to learn how to correct whatever is left from here, from the system. So these are our baselines and our systems, and this is the first set of results. So in the x-axis here, this is the learning curve. So we split the training set. So the full training set is around 13 or 12K of pairs of morphological representation and spoken form. And we split those into the very low resource from 100 examples to 1,000 examples with 100 entries as increments, and then from 1,000 to the full data set with 1,000 increments. And this is log scale. That's why it's different. And then on the y-axis, you have the accuracy, which is a full match of the surface form, the goal surface form and the predicted surface form. And so right ahead, so at the low resource up until 2K, the rules outperform everything. And then the residual system, the system trained on the residual outperforms the baseline of the transformer on its own when it's trained on the MR and SF. And then this blue line is basically just copying. So copying gets you, so 60% of the dev basically means that it's just, there is no operation. So we are really working with 40% here. So yeah. And then once you have, once you get up to 3K, the transformer that has been trained on the normal data actually starts to pick up, performs slightly better than the residual, which also performs slightly better than the rules themselves. And so this is the scenario where we have all the rules, basically. But what if we don't have all the rules? What will happen if the linguist fell short and didn't give us all the rules, or we only have very limited knowledge of the dialect, of a new dialect, for example, and we only know few rules? What would happen? So we conducted another set of experiments. So I just color-coded these just to have, reference to the previous numbers. And we started by applying one rule at a time. So we start with the rule number 1, and we add the second rule, third rule, until we get to all the rules. So this column is just the results that I've shown. And so, once we zoom in on the lowest resource, so this is, can imagine this as a scenario where we don't have a lot of data, and also we don't have a lot of rules. Or we have some data from some dialect and rules from some other dialect. So we can see that with the less rules we have, the residual system, so these numbers are basically the residual, the transformer residual. The less rules you have, the better the residual helps until we get to all the rules. So bolded means that the residual system is doing better than the rules at this point. So the residual system helps really well when you don't have a lot of data. And so this brings us to the end of this presentation. So there are two main points here to drive home. So a comprehensive set of handcrafted linguistic rules is more accurate than any system, really, when you have very little data that you're trying to get the phonological representation from. And then when we have an incomplete set of rules, a residual system that learns how to correct those errors from the rules boosts the performance really well. And then for future work, so as I mentioned, as I hinted, that this is really useful in the case of cross-dialectal modeling. So we have lots of different low resource scenarios, either low resource in the end being understudied, or low resource, we don't have a lot of data. And also the rules themselves, this is very relevant if we are trying to also study language acquisition, the computational models of language acquisitions. It's very analogical to these types of rules. And yeah, that's it. Thank you very much.
Thank you, Salam.
Great work. Thank you for the talk. I have a question about the linguistic rules. Do you think it's possible to actually learn them in the data instead of having a linguist going to?
So that's a great question, because this project is actually a spin-off of a much larger project that I'm working on that is going to basically be the topic of my dissertation, is learning those rules automatically. So the entire process is automatic. And I have preliminary results from that work in ACL of last year. You can look at that paper as well. Yes.
Yeah, very nice work, by the way.
Thank
It's
you.
very interesting. I will just ask a more general question,
Okay.
maybe more to your dissertation. If someone asked you, what is the application of this in the era of LLMs? What would you say?
So the main focus when I was looking at this work is because I worked with morphological analyzers, which are like very deterministic lexicons. And like the one thing that we usually sometimes want is the phonological representation. And so knowing that these can be, we can have rules for them, it would be very useful to also encode those in a morphological analyzer as a separate resource on its own, if we want to have those. And those resources can be part of other systems.
I had a related question
Yes.
about rules. So since you did that experiment where you slowly added the rules,
Yes.
I was wondering if you've looked at this old work called Transformation-Based Learning by Eric Brill. If you haven't, Owen knows about it, so you can ask him.
Owen knows about it.
Yeah.
He mentioned it a couple of times,
Right.
but I haven't really looked
Right.
in
So
detail.
the idea is that you create a template for generating rules. Like,
Okay.
so these would be rules that would be more than anything anybody would ever need. And you'd learn which ones to apply by going through the data.
I see.
And as a result, so it's a little bit like saying have a regular expression that generates all kinds of rules, including the correct ones, absurd ones, things that are dialect specific versus universal. And then with your data, you learn which ones to apply.
So in my other work where I learned this automatically, I actually do something very similar. I generate, from each point, I generate a lot of rules, and then through some metric, I choose the more general rule to apply through all the data.
Thank you very much, Salam. So now we move to the next talk. So the title is Event Arguments Extraction, Corpus, presented by ALKhamissi and Lina Davis. I am also co-author, me and Muhammad Khalili. So please.
Hello, everyone. I am ALKhamissi from SIGARAB at Residuals University. I will talk about our work at Event Argument Extraction Corpus and Modeling using BERT for Arabic, which I co-authored by my colleagues Lina Davis, Mustafa, Jarrar, and Muhammad Khalid. Let me first notify that the corpus and the model in this presentation are all one of the available open source NLP tools that we have developed by our team at SIGARAB. The motivation behind constructing such corpus and model is that understanding and extracting events from a text is very important in various NLP applications such as insurance, decision support, disaster monitoring, emergency response, and many more. But it is noticed that there is a significant gap in the availability of comprehensive annotated corpus, especially for low resource languages like Arabic. So to bridge this gap, we have developed the corpus and the models. So in our approach or in our method research, we focused on extracting relations between events and their arguments from unstructured text. So we have an input sentence with a predefined named entity, and our goal here is to extract the relationship between event entity and other named entity within the same sentence. Specifically, we focused on three relations: the has location, has date, and has agent, relations within the same sentence that describes events. Our key contributions in this research is that first, we construct the وجود حدث corpus, which consists of about 550,000 tokens that are manually annotated for event argument relations. And from this corpus, we generated the HadathNLI dataset, which comprises about 25,000 premise hypothesis pairs. We have also developed a novel methodology for event argument extraction by framing it as a natural language inference task, which achieves a high performance. And we also, in addition, construct وجود out of the main corpus, which additionally another annotated corpus for event relations, which comprises about 80,000 tokens dedicated for out-of-domain evaluation. And finally, we developed an end-to-end system for event argument relation extraction. Now,
وجود حدث corpus is the corpus that we constructed for the event arguments. وجود is a rich Arabic nested named entity corpus that contains 550,000 tokens. It contains 2,772 annotated events. In order to construct an event argument corpus, we identified the event arguments and established relationship between these arguments and the respected event entities. The relationship types that we manually annotated for the event arguments are the has agent relation, which specifies the participants that are involved in the events and can be of the entity types, person, organization, occupation, or named entities. The has location relation indicates where the event happened, and the has date points out when the event occurred. وجود حدث corpus consists of 1,974 annotated events with, as you can see from the table, the total count for each relation. The total for all relation is 2,588. Our annotation guidelines that we established for annotating the event arguments, I will tell them in short. First, the event arguments are only recognized within the same sentence. Second, sometimes some entities refer to the same person, but they must have different IDs. An event can have multiple agents, and two entities can share the same arguments in a sentence. As you can see, the examples are more explained in the paper. To evaluate the quality of the annotations, we used the inter-annotator agreement. We randomly selected 5% of the annotation for evaluation. As you can see from the table, the scores for the F1 score and the Cohen scale.
Now, our methodology for event argument extraction. In our research, we propose to frame the relation extraction for events as a natural language inference task. In this methodology, we have two input sentences, the premise sentence and the hypothesis sentence. Using a transformer-based model, we can classify we can classify it to true or false, indicating whether the premise sentence entails the hypothesis or not. Here is two examples. In the first example, the premise entails the hypothesis, so we labeled it as a true, while in the second example, the premise does not entail the hypothesis, so we labeled it as false. In our approach, the premise sentence is the input sentence, while the hypothesis is created using a template which presents a possible relation between an event and other named entity within the same sentence. Then we use a BERT model to classify whether the input sentence entails the hypothesis or not, indicating the existence of the relation. So to train our model, وجود حدث is a corpus of relations, so we need to transform it into a data set of sentence pairs of the premise and hypothesis. To do so, first, the entity type is playing a crucial role in selecting the template for creating the hypothesis. For the positive hypothesis, we use the arguments that are annotated as arguments for creating the positive hypothesis. While for the negative pairs, we use entities that are not annotated or not linked to the events as negative pairs. Here, for example, غرب دير البلح can be used to generate a positive hypothesis for the event قصف مدينة خديجة, while وكالة وفا can be used to generate the negative pairs. The final data set consists of training and testing pairs. For the training, it consists about 20,000 pairs, while the test about 2,000 pairs, totaling about 23,000 pairs. We trained our model by fine-tuning it on our BERT version 2, using weighted cross entropy loss and contrastive loss as an objective. Our performance, our event argument extraction model performance on حدث NLI is about 94% F1 score. This demonstrates our models to accurately extract the relations. However, this high performance must be validated to generalize it out, to validate or to ensure our model ability to generalize across diverse domains and contexts. So we conduct another out-of-domain experiment using another additional out-of-domain corpus, which is Wujud out-of-domain. Wujud out-of-domain corpus is a manually collected corpus that is manually annotated, which is manually collected from news outlets such as Al Jazeera or Al Arabiya. It covers 10 distinct domains and covers events from years 2010 to 2022, which consist of about 80,000 tokens. The model performance on Wujud out-of-domain is 83.59%, which is also high performance. Our end-to-end system consists of 3 modules: the named entity recognition using Wujud web service, the template selection to select the appropriate template for the recognized entities, the event argument extraction module that we previously trained, and finally the output. The baselines on Wujud Hadath is 93.99%, while on Wujud out-of-domain it is 74.9%. And finally, we have Wujud out-of-domain, Wujud Hadath corpus, and our event argument extraction model, and our end-to-end system. Thank you.
Yeah, questions.
I have 2 questions. The first is an easy one. Did you think about creating your negative examples not by choosing agents or whatever that are not involved in the event, but taking them from the event but changing their role? That those would be harder negative examples. That's one question. The other question is, any plans for extending this to social media text? Because it looks like all the text you have is fairly well-written text. So I guess you can answer either question or any order.
So we can change it to any other context, but we focus on Wujud, but we can change it with any context.
Also, the negative examples from the event participants, because then it's harder than like that.
So for the false or negatives, it's actually it's not possible to change it because it's one direction relationship. So from event to organization, from event to location, you cannot make it vice versa because you already have the named entities.
Hi, thank you. Very nice work. I particularly like the idea of converting the relation extraction task to an NLI task. I wanted to ask about this conversion of the task. There's some work in this domain that takes relation extraction and reformalizes it as a question answering. And there is some evidence that this is good both for models. They can be fine-tuned on question answering, and then perform a better relation extraction. And it's also, to some evidence, it's good for human annotation, so better agreement when you rephrase the relation extraction as question answering. So my question is, if you have considered or compared, perhaps in preliminary experiments, the method of converting it to NLI versus converting relation extraction to question answering, if this was under discussion or tested. Thank you.
So you mean instead of having NLI, having the problem as question answering? You want to answer?
We can make this later, but we compare it with another method, not with the NLI. We compare it with the graph neural network method, and it demonstrates higher performance compared to about 60% on graph neural network. But on a question answering, we did not, we can conduct it later.
We give, oh, okay. Maybe last. Yeah, it's actually my paper and I cannot, so we give 1 minute to each of the extra to the presentation.
Thank you for the good work. I just had a very, very quick question. Have you tried maybe GPT-4 as a baseline? Maybe with in-shot, prompting? Okay, maybe you should. I mean, like, just for comparison, just to know where things are.
Thank you very much. And we like to have questions during the break. So. Okay. So the next talk will be exploiting dialect identification in automatic dialect text normalization. Bashar Al-Hafni, Sarah Twaiti, yeah. Zaid Fawzi, Fatima Nasser, Fadil Riyani, Huda Bouammar, and Nizar Habash.
Quick question. Does anybody know how to make this full screen? Huh? No? Okay, shortcut.
It's a PDF.
Yeah.
Okay, it's not PDF.
Wow.
You can start.
Control L? I love you. Thank you. All right. Good morning, everybody. I hope you've been enjoying the conference so far. I am Bashar Al-Hafni, and I'm a computer science PhD student at NYU. And it's a true pleasure of mine to be presenting our work on exploiting dialect identification in automatic dialectal text normalization. This is joint work with my colleagues Sarah, Ziyad, Fatima, Fadl, Huda, and Nizar. So starting off with a motivational example of a famous dish from the Levant region that consists of fried tomatoes, and we call it al-laad bandura. Now, this dish is not very famous in Egypt, hence the sentence, I didn't fry the tomatoes. The sentence can be translated into Egyptian Arabic as ma'alitsh al-uta. However, since Arabic dialects don't have standard orthographies, the sentence can be written in so many ways that reflect the phonology and etymology of these words in Egyptian Arabic. Now, this phenomena is typically referred to as spontaneous orthography and can result in a wide range of varieties for a given input. Now, this high degree of sparsity poses major challenges on NLP applications. So for example, if we prompt ChatGPT to group these sentences based on their possible English translations, we get the following groups. So we get things like, I didn't say the lowest, I didn't say the tomato, I didn't fry the lowest, and so on. Now, some of these translations are actually correct in some contexts. So for example, if you look at these varieties in group 1, these can actually be read as ma qultish al-awta, which means I didn't say the lowest in Egyptian Arabic. However, that was not the intended meaning of the original input. So we can see that the system actually here is struggling with this larger space of possibilities, and maybe reducing this huge space could actually aid ChatGPT in arriving at the correct answer. And that's where text normalization could be really helpful. Another issue I would like to highlight is the issue of dialectal variations in Arabic. So Arabic dialects vary phonologically, lexically, and morphologically. So for tomato, we have many lexical items across the Arab world. So we have bandura in the Levant region, tamatam and uta in Egypt, and mtisha in Morocco. Now, if we would like to normalize the sentence, ma'alitsh al-uta, I didn't fry the tomatoes, we have a wide range of varieties or possibilities to select from. But if we can condition text normalization on the dialect of the writer of this sentence, we might be able to reduce the space. So for instance, in Levantine, we know that the lexical item for tomato is bandura. And therefore, uta over here cannot be the lexical item for tomato and can only be read as auta, meaning lowest. Whereas for Egyptian, it could be actually more complicated and can refer to either tomato or lowest, and that's why looking at more context would be really helpful. So what can we do to actually integrate dialectal information within text normalization to improve performance? In this work, we report and explore the task of codification, which is defined as normalizing dialectal text into the conventional orthography for dialectal Arabic, or CODA. The input to our models is a dialectal Arabic sentence, and the output is a normalized version of that sentence in the CODA convention. We studied the effect of dialect ID on the task of codification, and we focus on 5 dialects: Beirut, Cairo, Doha, Rabat, and Tunis. And we benchmark pre-trained sequence models on the task of codification, and we report on a variety of systems. Now, in terms of CODA and dialect ID, CODA was developed by Habash et al. In 2012 for computational purposes with the following goals in mind. It's designed for all Arabic dialects to basically minimize differences in choices. CODA uses the Arabic script, and it's easy to learn and very intuitive. One important thing to note over here is that CODA does not convert dialectal text into MSA. Historically, it started with Egyptian and it got later extended to many other dialects like Palestinian, Tunisian, Algerian, Moroccan, and so on. In 2018, Habash et al. Introduced a unified guidelines for CODA across many CETA dialects, and they refer to it as CODA Star. And you can check out the guidelines for CODA on this QR code over here. So as an example of what CODA actually looks like, so over here at the top, we have an Egyptian Arabic sentence in the CODA convention, and we can see how the spelling varieties of each of the words in that sentence could actually be standardized and normalized into a single form. So it reduces the larger space of possibilities that the spelling variants could actually have. Now, dialect ID is probably the most famous task in Arabic NLP, and it's basically about assigning or predicting the dialect of a given input text. And it's been really helpful in a variety of NLP tasks, such as machine translation and morphological tagging. Now, in terms of our data, we use the Madar CODA. Let me just move this, because it's annoying. Oh my God, I made it worse. I made it worse. Do what? Thank you very much. All right, so wait. All right, for our data, we use the Madar CODA corpus, which consists of 10,000 sentences from 5 Arabic city dialects. So again, Beirut, Cairo, Doha, Rabat, and Tunis. These sentences are parallel across the cities. So we have 2,000 sentences for each city. And each one of these sentences was manually annotated for CODA. So we have a parallel corpus of raw sentences and their codified versions. For the splits, we split our data set randomly into train, dev, and test per dialect by following a 70%, 15%, and 15% split respectively. Now, for our approach, we frame the task of codification as an autoregressive distribution. So given a dialectal input sentence X and the dialect of X, which is D, the goal is to produce a codified version of X that is Y. In our work, we focus on 2 sequence models, so AREEj and RT5 version 2. To obtain the dialect of each sentence in our work, we use the DID component that was built by Salam et al. 2018 that's available in Camel tools. Now, to integrate dialectal information within our models, we append a special dialect control token to the input sentences, and we explore 4 control tokens. So we have the city control token, which is basically the city dialect in Arabic. We have the MSA phrase and the dialect phrase control tokens, which are basically simple phrases that follow the template in city we say. So for MSA, in the case of Beirut, we have في بيروت نقول, whereas in the case of DA, we have في بيروت منقول. And lastly, we just explore with a simple ad hoc digit that we assign basically to each dialect. Now, in terms of our baselines and systems, we start off with a very simple word level lookup model that was built based on MLE. So the goal of this model is that given a word and its bigram context, the goal is to look up the codified version of that word based on the training data. For the sequence models, we train them into two different setups. So we have a joint setup where we train the models on all the parallel data that we have. And we have an ensemble setup where we train 5 separate models, one for each dialect. And during inference, we use DID to pick the corresponding model for that dialect. Now, for evaluation, we frame the codification task as a grammatical error correction task, and we use the max-match M2 scorer that computes precision, recall, F1, and F0.5 on the span level of the edits that the system made against the gold data. And we also report word error rate. Now, in terms of our results on the def set, our MLE baseline achieves an F0.5 score of about 61 overall. Now, for the sequence models that do not use dialectal information, AREEj was the better performer compared to BERT in both the joint and the ensemble setups. And when we add dialect information, we see that the AREEj joint model with the city control token was the best performer with about 86 F0.5. Now, moreover, we also approximate an upper bound by using the gold DID label during inference, and we also observe consistent conclusions. Now, when it comes to the dialect-specific results, the best model, which is AREEj plus the city control token, improves over the AREEj baseline across all dialects except for Cairo and Tunis. When it comes to the test set, the AREEj joint model plus the DA phrase was the best model with 86 F0.5, and it improves over the AREEj baseline on all dialects in terms of the dialect-specific results. Now, we also conducted a manual error analysis where we took about 100 erroneous words on the def set, and we classified these errors into 6 different types. So we have non-coda errors. These are basically plausible spelling of the words, but they are incorrect in coda. So we have things like تحدثت in coda versus تحدثت. We have hallucination errors where the model was way off, or the outputs could actually be related to the morphological form of the input. We have valid errors like hamburger, as you can see over here, and these typically occur when we have foreign names. And then we have punctuation and deletion errors. In conclusion, we explored the task of codification, and we reported on pre-trained sequence models. And we showed for the first time that using dialect ID information can actually improve on this task. In future work, we plan to extend our work to other coda data sets and evaluate the added value of improved codification on downstream tasks like machine translation. And we plan to develop models for coda error type classification. Thank you very much. And our models are available on Hugging Face. So let me know if any questions.
Now, Fadi.
Thank you, Bashar. Nice work. One question that I actually thought about when I read the number of the valid mistakes. How canonical is the coda, let's say the codification using coda? And why does it allow us to have valid 13%? Like if you have valid 13%, those can actually be compensated in the precision and recall computations.
Yeah, that's a good question. So these valid mistakes typically happen for foreign names. So there's actually no correct way of spelling them, or like a standard way of spelling them. Now, one way to mitigate this is basically by either having multiple references for these valid names, multiple spellings, or basically have a morphological analyzer that goes over them and just basically discount the morphological, the foreign names if they appear in the input.
Thank you, Bashar. Excellent work. It's just a general question about your work. You just consider limited dialects. Do you think this method can be applied to the different other dialects and can be performed also well on other dialects?
Yeah, absolutely. And that's what we're planning on doing in the future. So there is the Gulf coda and the Palestinian coda as well. So we're planning on applying this work on them as well.
Okay, very interesting work. I just am a bit confused about how the evaluation is happening here. So, for example, the first one, it actually corrupted the word. So how do you measure in this case? Because actually you might have this one needs to be corrected, and then actually use another one, it was fine, then actually corrupted it.
Yeah.
So how this is incorporated, especially in the table here. No, can you go for the large table?
Yep.
Do nothing. No, the table where yes.
Yeah.
Do nothing. The position is 100%. Recall is 0, and F1 is 0.
Yes.
How this is calculated?
Right. So this is the M2 scorer. So the M2 scorer is a common metric in grammatical error correction task. And the way that it works is basically given a parallel data set, it runs an alignment algorithm to see basically where the changes have to happen. So you have a sequence of edits that the system has to basically make. And the precision recall and F1 are basically computed over these edits, right? So if a system basically passing the input to the output as it is, the system is 100% precise, but it did not recall any of the edits that it has to make. That's why the F1 is basically 0 over here. Exactly. So this basically, you can see this result in our table over here. So you can see that the precision is lower than the recall in case of Cairo and Rabat, in case of Cairo and Tunis. And that's exactly what happened over here by doing an error analysis. So it does look at the overall edits over the whole corpus, basically. So it's not a word, it's like an edit-based metric, not a word-based metric.
Yeah. Thank you so much for the nice talk. Do you have any idea why the different control tokens result in such variation in the results?
The difference in what? I'm sorry?
In the control tokens? Like, why do some control tokens work better than the other? Like the city, and you had the other MSA phrase and the DA phrase and the number. Do you have any like intuition as to why one works better or the other?
So I think this could be related to the pre-trained data that the model basically saw during pre-training. I know that I think AREEj did not have dialectal text in the pre-training setup, but AREEj did. So I think the more specific the phrase is, the better the results are going to be.
Thank you very much. So questions more during the coffee break. So
thanks.
So, hello everybody, assalamu alaikum. So we'll start our session now. The session is about downstream applications. We have 3 talks. The first one is strategies for Arabic readability modeling, presented by Professor Nizar Habash.
Hello, everybody. So I'll be presenting this work that was done with my students, Juan Piñeros Liberato, Bashar Al-Hafni, and my colleague Mohammed Al-Khalil. This project was actually a undergraduate senior project that ended up, he kept working on it in the summer and was working a bit before, but it was essentially a senior project. Our projects go on for a year in NYU Abu Dhabi. So when we talk about readability, what we're talking about is basically coming up with a way of quantifying the degree of complexity of a text as far as the concern of comprehension of a particular audience. So to be able to say, if we see a text like the text that we have here, words like زمن, في زمن مضطرب لا يركض عجاجه, we expect that this would be harder on an average reader. We expect them to have certain skills to be able to do it. So we would give this, let's say, a level 5. The system we're using is based on the SAMR system, which I'll mention also in the talk, and it has 5 levels. And compared to something like في زمن صعب لا يهدأ غباره, the expectation here is that this is a bit easier. The vocabulary is easier, the imagery, the intended communication is about the same. Obviously, it cannot be exactly the same. Words have meaning and there are reasons for them. But the idea here is that we want to be able to, given a text coming into us, can we identify which of these 5 levels, in essence, it can get? So that's kind of the big picture of the task. And why do people work on readability? You can think of it from a couple of different points of view. For applications that are intended for creating materials for human use or rating materials for human use to kind of decide this is good reading for a child of a certain age, of let's say 6th grader or 9th grader, so that we actually encourage them to enjoy the language, kind of like instead of having the sorry if I speak in Arabic, the emotional complexities connected for some people with, Arabic is very hard, etc. So figuring out how to grade that level for them so they can enjoy it more and they build their skills in the language. And also from a machine point of view, it opens up the space of controlled generation or rewriting. So kind of controlled simplified text or targeting a translation into a simplified target in this case. Lots of work has been done in this area. This is not, in essence, new as a big idea, but it was done in English. And our interest was to kind of develop resources and data sets and work on it in the case of Arabic. So what we do here is, I'm kind of annoyed by this too. I'm going to follow your advice. 1 second. What is it? Thank you. Excellent. So the idea is to define the task in the context of Arabic, explore a number of different techniques, from very simple techniques to more complex techniques and their interactions with the other, and highlight the different advantages and weaknesses of the different approaches. This is the wrong audience to tell them about Arabic. You know about Arabic complexity. Morphology and orthographic ambiguity are some of the bigger issues, of course, for us. And, this is, yet another one of them. Almost in Arabic, I love it. You can pick a word at random, and there is a world of interesting mysteries in it. This is my recent favorite one, where it's wali'ina, wali'ainin, and wala'inun, completely different meanings with also different readability levels. Ain is plausibly a simple word, and wala' would be probably a harder word, or harder than ain. Now, the work was done under a big project called the SAMR project, or stands for Simplification of Arabic Masterpieces for Extensive Reading. This was work that was funded by New York University Abu Dhabi and was co-led by my colleague Mohammed Al-Khalil. And the goal was to create resources with the intent of simplifying the text from Arabic fiction to students, let's say in middle school and elementary school, upper elementary school. We've created a number of resources. The website of the project, samr.camellab.com, has all of these resources, which include lexicons, readability thesaurus, also simplification interface, where you see the text and it's labeled with colors that you can use to edit, and also a simplification corpus. And what we use here in this work is the data comes from the simplification corpus. For that, we took 15 publicly available, out of copyright Arabic fiction novels. So these are all kind of books from the 1950s and 40s and before. And the total was about 160,000 words. It's a small bag of money that we use to do this annotation. We basically, if you want to say translated or restyled or paraphrase the text to go from the original level, which we considered level 5, they're all quite actually hard to read, to a level 4, which would be equivalent to a 9th grader, almost, and a level 3, which is about a 6th grader, roughly. And the technique was relied heavily on using the SAMR lexicon. It was not an automatic technique, although there was an initial step to label the words with a guess. But the human annotators actually would take the sentence and rewrite it in the context so that it fits the meaning, lowers the level, and it's validated by the validator of that its vocabulary is of the right level. And we basically targeted beside the original in that work, we had level 4 and level 3. So that basically says this corpus is annotated effectively. We can think of it as annotated as 3 levels: at the document level, at the fragment level. I'm defining fragment, not sentence, as basically a continuous sequence of words separated by any form of punctuation. And this is not to say this is what we should use. It just says when we're evaluating, it's a unit that we're deciding on, that we're evaluating at that unit. And this just helped us making a lot of decisions a bit simpler for us.
And so while in the corpus, we may have an example like this. فأشارت إليها فربض واحد إلى يمين الفتى. This is a weird sentence because the إليها is referring to a number of dogs. So عدد من الكلاب. So one of the dogs came and sat next to the child. So out of the context is actually very hard to do. And you can see the different versions. ربض becomes جلس in that case, which is a reasonable mapping. Now, we didn't actually use the generated versions like level 3 and level 4 that the humans produced. We did not actually use. What we used is basically, we used them as indirect annotations on the original to tell us which words are of level 5, 4, or 3. So if the word was changed, going from the original to 4, it's a 5. If it did not change, it's maybe a 4 or a 3. Now we look, did it change when it went to 3? If it didn't, then it's 3 all through. So you get the intuition. The details about this are in the paper. We naturally divided this into train, dev, and test for the purpose of our experiments. And we basically report here on leveling at the word level and at the fragment level. There's a very simple definition of what's the level of the fragment. It's the highest word in the fragment. So if you have a single 5, the whole thing is a 5. If you have a single, and so on. All right, so we tried a number of different approaches, starting with the simplest thing, so that people, reviewers, and Sanjeev would ask these questions. What is the simple regex? So we did estimate an MLE simple estimation just to see where we are when we start. We have a lexicon approach, which uses the camel tooth disambiguation, and then takes the lemmas and bases the decision based on the lemmas for the leveling using the SAMR lexicon. And we also took intuitions about frequency-based models. So we have about 12 billion words that have about 11 million types of their frequencies. And we kind of tried different ways of the intuition of the more frequent words are simpler, the less frequent words are harder, which is generally true. There's a high correlation, but it's not precise enough to give you really what you need for this kind of task. We tried it completely just based on the frequencies. That's the distribution approach. And we tried it based on the examples, where we basically took some examples in bins and we said, if there's enough 3s or 4s or 5s, that labels all of its neighbors and frequencies. So these are just, we're trying to see like, what is the laziest thing that we can do without using annotated data, without using other things so that we can succeed. We also had a BERT classifier, just fine-tuned. We used the Camel BERT MSA for this. And we tried a large number of system combinations that included like running one model followed by the other. The basic intuition here is that some models fail and we know when they fail. So an MLE system, if you don't know the word, you don't know the word. So what do? You back off to some complex technique or a default, etc. So at the fragment level, we tried the approach of aggregating the decisions of the words. Label, pick the highest one and assign it to the fragment. And we also did direct classification with a BERT fine-tuning at the level of the fragment. So the results, in short, I mean, you can see kind of the numbers. If you take just a default level 3, just want to point out that the F1 score for the label 3 is 92%. That's right. If you don't do anything, you get 92% on level 3 because most of the words are easy, right? It's all of the fi and min and an and ala and all of these other words. So that's kind of not that hard. Yes, thank you. That's not hard. But then the F1 score is basically the one that shows you, how good you're doing. So truly our baseline is about 30% F1 score. And with the basic BERT fine-tuning, we get to about 74.5 F score. When we start adding the other models, like the MLE and the LEX models, those numbers do bump up a little bit. And the paper has the full set of experiments that we did here. The short story, I'm just going to aware of the time, is basically an optimal combination that included this idea of really simple, super classical idea of tuning the MLE model, meaning what do you define, your trust point of what is an in vocabulary, out of vocabulary, or you trust it. So if it's above 85% of the probability space is going with one reading, we went with that. If it was more ambiguous, we pretended it didn't exist and went with another model. The point is that even these simple, super simple techniques that are highly precise, if they're used in the right way, they can actually help you, particularly with the amount of data that we have. The dev results on the fragment levels also showed consistent approach where the aggregation did better, in fact, than the fine-tuning directly.
And the test results were completely consistent with everything else. So I'm going to jump to the end because I'm worried about the time. The different models participated in different levels in the making of the decision. You know, in the best system, the MLE ran first, as I showed earlier, then the Lex, then the BERT. So even though things that were affecting less decisions that they're making, you know, they're coming in the right moment when everything else that we trusted failed. So even with that, it's not that their accuracy was actually of their decisions was actually a bit lower, but overall they helped us because the accuracy of the other systems in that space is zero, basically. We don't know anything. So I'd rather have something with a 30% error rate than something with a 100% error rate. And just for fun, some of the error analysis cases. There were cases where the input has spelling errors, which kind of confused our system, which expected things to be more correct. There were also cases where we thought the gold annotation was a bit aggressive, like فقطعا الطريق فمشيا في الطريق maybe are not really that, you know, different in terms of leveling. It's a hard task with some amount of subjectivity in it. And also things where let's say the model just get confused between mehd as cradle and mahad as paved, and those are associated with different levels. I think we're very happy to report on this work. All of the data is publicly available. All of our techniques and code is publicly available. And we hope to basically keep on working on this. There still is a range of errors there that can be handled using other linguistic ideas and features, particularly ideas from syntax, for example, to be included in it. And as I said, this is publicly available. And I hope I have a minute of questions because I just ran out of time. Thank you. Hey, Karim.
Yes. So the first question is, have you considered doing this not for MSA necessarily, but for dialects, because dialects can be particularly difficult? And the second thing, you focused on the lexicon here. Do you have any thoughts about the syntax also, because syntax can contribute to the difficulty?
Yeah, fantastic question. As far as the work on the dialects, we have not actually done work on doing kind of the mapping. We have to think a bit more about like the definition of the task and who is the audience. Are you talking about, let's say, a child versus an adult speaking in the dialect, and at some point, like what's the relationship between that and some form of simplified standard Arabic that adults may speak versus not? To another dialect, that's right. So any form of kind of restyling or retranslating between them is definitely a really interesting space. I can tell you from an ongoing project called Badr, which is a readability project we're working on now. We don't have any publications on it yet, but the website is out there. We're actually looking at exactly that question, but in a slightly different way, which is if a word is actually known in the dialect, we would expect it to be an easier word in the standard for readers, right? Which seems like a very natural thing. So we're trying to now annotate, but we're annotating across multiple dialects to see, do they actually even agree on this idea to start with? And I forgot your second question, I'm sorry. Oh, syntax. So in Barak, we actually have special annotations on syntax for this, and we don't have it here.
I have the mic. Yeah,
Okay.
thank you, Nazar. I just have a question about data-driven versus knowledge of experts in the field of readability outside computer science. Can you say something about this?
Yeah, so the annotations were all done by humans. I think this should be the last question. I'm really sorry about the next talk taking their time, but all of the annotations are done by linguists who know the language very well, who have taught in schools, some of them. If you check out the Samer lexicon paper, we actually compare 3 people from 3 different countries, even though it's all standard Arabic, and we actually show the degree of compatibility between them is quite high. So there is actually a lot of insights there. In Badr, there's even more insights because my co-PI on that project is Professor Hanada Taha, who's famous in the field of Arabic pedagogy for her Hanada Taha Arabi 21 readability leveling system. So we're actually working with somebody who actually did this officially, for publishers, and we're trying to see if we can use AI in that space. And I thank you very much. I'm happy to take questions in the breaks. Sure, go ahead.
في البريك.
Who's the next speaker على فكرة? Come in, Khaled.
So in my opinion, just quickly, and we can discuss it in the break. Readability is a problem, is not well understood, in my opinion. Is not well understood. Readability in speaking or readability in understanding. Is it conceptual when you say كينوني ولا كائن ولا شيء? Is it يعني المقاطع So it's also contextual readability. So sometimes if I say a word in a context, you understand it. In another, it becomes complicated. I think not only in Arabic, but in NLP community, the readability is not really well defined.
Okay, that's a good comment. I can tell you about it, my opinion in the break. Thank you.
Thank you. Thank you, Nizar. So our next speaker is Khadija, and collaboration with Johanna. Large language models as legal translators of Arabic legislations. Do ChatGPT and Gemini care for context and what? And terminology.
Okay, thank you for presenting me. Thank you, everyone. Okay. Can you hear me? Okay, so my name is Khadija Ait Lefqeh, and I come from the University of Naples L'Orientale, where I am affiliated with the Junior NLP Research Group. Today, I am pleased to be here with you to present my paper along with my professor, Joanna Monti, titled Large Language Models as Legal Translators of Arabic Legislation. We're going to attempt to answer the question whether ChatGPT and Gemini care for context and terminology. The flow of my presentation is as follows. I will introduce the research problem and objectives, followed by experimental setup and methodology, along with evaluation and results, and then the conclusion and future works, and finally, the references. Well, large language models is the hottest topic of under discussion nowadays. Because they demonstrate significant advancement in many NLP applications, mainly machine translation. And in here, I specifically refer to ChatGPT and Gemini. However, they have not been thoroughly investigated for domain-specific scenarios, such as the legal domain for Arabic, where religion, culture, and law meet and mutually influence each other. Therefore, my work targets the evaluation of zero-shot prompting of ChatGPT-4 and Gemini as legal translators of legal terminology in Arabic legislation into English and French in two scenarios, in context and out of context, against our gold standard data set. Based on the accuracy criterion, the application of multidimensional quality metrics, and we're going to also identify the LLM's technical flaws and suggest rooms for improvements accordingly. Well, to start with our evaluation, we need data. Therefore, this slide shows the workflow of developing a monolingual term base and a concordance list. To do this, we use Nuj, which is an NLP software application to develop an Arabic monolingual corpus, from which we semi-automatically extract legal term candidate and concordances with the help of Nuj linguistic resources and grammars. This process is then submitted to the post-processing, where we vocalize, delete irrelevant terms, and add new ones that were not recognized by the extraction operation. And the output is a monolingual term base and a list of concordances. This table shows the documents the documents used to develop our corpus, the countries, and the tokens and the total of tokens. To follow up with the development of our gold standard, the monolingual list of terms and concordances needs to be translated. So the first phase is the translation, and the second is the equivalence check. In here, the translations were done, were used. The translations are to ensure the accuracy of the translations. We consult the online gateways to European Union laws, mainly EURLEX, and the official term base, the famous IATE, and the concordance search tool, Jeremy. to ensure the accuracy and adequacy of the results in the target language. And then this list is submitted for a legal expert for validation, thanks to a research group at the University of Law in Qadiyad University in Marrakesh, in Morocco. Our our final output, which is our gold standard, is as follow: 1,015 out of context legal terms and 1,015 in context legal terms. So the terms and the sentences where they occur and the reference translations. Well, now that we have everything, let's start with our evaluation. So to evaluate the empty performance of ChatGPT and Gemini, we use a Python script that iterates through our data to generate prompts. It implements a series of prompts for both scenarios in the two language pairs. The first prompt is designed to provide only the results, the empty results, without providing additional context or comments. And the second prompt is designed to provide the Arabic legal sentences without providing the comments. And the generated output subject for evaluation is classified as follow: out of context and in context translation results of ChatGPT from Arabic into English and Arabic into French, and the same goes with Gemini. So now that we have everything ready, Bismillah, let's start with the evaluation. So our evaluation consists of two fundamental phases. The first is the accuracy criterion, where we assess the obtained results of both models based on the accuracy criterion against our gold standard data set. The second phase is the application of multidimensional quality metrics that is based on an error typology and the scoring model. The first phase in here, this table shows a comparison of ChatGPT and Gemini as empty of legal terms from Arabic into the Arabic into the target languages in the both scenarios based on accuracy criterion. So despite the slight variations of the true counts, both systems' performance decreased when the context is provided. Well, given the fact that the evaluation based on accuracy criterion is fundamental, however, they do not give like the final results or the final decision over the quality of the systems. It is at this point that we apply the MAQM, the multidimensional quality metrics. But what is exactly this MAQM? Well, it is a framework for analytic translation quality evaluation. It can be used to evaluate machine translation, human evaluation, and AI-generated translations. It uses a set of error typology, the so-called error, a set of error types, the so-called error typology, and the scoring model. So how exactly this error typology is used to annotate our data? Let me give you an example from the Moroccan Family Code. If I'm not wrong, it is from Article 125. That says يعتبر الفراش بشروطه حجة قاطعة على ثبوت النسب لا يمكن الطعن فيه إلا من الزوج عن طريق اللعان أو بواسطة خبرة تفيد القطع. If you can see the highlighted terms, الفراش, الطعن, اللعان والقطع, you can see that the translations given by both systems in the two target languages are somehow questionable. So if we consider the ChatGPT results of English, al-firash is translated as consummation, and at-ta'an is translated as challenges, and the li'an is translated into li'an itself, and al-qata is falsity. And if you consider the human translations, you can notice the differences. So how we annotate the errors? So the MAQM offers a set of error types and the sub-error types. So you take each example and you calculate how many errors that terminology, for example, or style, and the sub-errors that are found in each example, and you calculate. This process was done manually. The same goes with the linguistic conventions. You can see the sub dimensions and also the accuracy. So this is not the final step. The final, let's go to see how we can calculate how the scoring model of MAQM is to be used. So before explaining how we calculate the final result, let's explain first how this scoring model is used. So this is a ChatGPT for okay, I got stressed because it's 2 minutes. Okay, so it uses several factors to decide over the quality. We have the error severity multiplier, the severity multiplier, penalty multiplier, and the error types, and the error type weight, and the error penalty totals. What is important is the absolute penalty totals and how it is calculated. So we take the error counts, we multiply it by the several multiplier, and then multiplied again by the error types. And the absolute penalty total, which is the final decision, is the total number of the error type, is the error type penalty totals. So, as conclusion, in Arabic and English, Gemini surpasses ChatGPT in achieving less critical errors in out of context. Conversely, for the in-context, ChatGPT demonstrates less critical results, but more minor and major errors compared to Gemini with only slight differences regarding the critical errors. In the Arabic-French pairs, ChatGPT and Gemini achieves better results in out of context, but faces significant challenges when the context is provided. MAQM indeed provides a granular assessment of the accuracy state of the model better than any automatic metric would do by considering various dimensions such as terminology, style, linguistic convention, accuracy, and audience appropriateness and their respective subdimensions. We believe that efforts should be invested in enhancing context sensitivity of LLMs, MT tasks. Therefore, our future implementations consider fine-tuning these models with extra context to improve in-context learning abilities, translation quality, and adherence to the domain terminology and style. We consider also leveraging the prompt engineering approach to enhance the performance of some LLMs in zero-shot and few-shot learning for Arabic machine translation tasks in the legal domain. We also intend to extend this evaluation framework to additional domain and language pairs. These are the references used for this work. And thank you.
Thank you, Khadija. Questions?
Thanks a lot for the really amazing talk and actually for covering this topic because it's actually not everyone would cover these kind of things. I just actually a general question. How would you describe more your text? Is it legal or because it feels from the example you said, is it legal or Sharia law, for example, or it's a combination of both?
It's combination of both. So the documents that were used to develop my corpus, which is they are from different Arab countries, because I want to consider the fact that, for example, let's say the term ma'dun, okay, in Egypt it is used to refer to the person who drafts the marriage contract and everything, but in Morocco, for example, we call it l'adul. We don't call it ma'dun. So I want to make these differences in terminology and the translation of these kind of terminology clear.
And this actually data is covering both, and is it released?
No.
Hopefully you'd release it one day. It's an amazing resource. Thanks.
I promise I will do.
Okay. So there's a question online from Zoom. Somebody's asking, have you checked the result sensitivity to the prompt and any prompt fine-tuning techniques?
Can you please repeat?
Have you checked the result sensitivity to the prompt? How sensitive the result is to the prompt provided?
No, actually, I didn't consider.
And have you tried any prompt fine-tuning methods?
Not yet.
Okay, thank you.
Thanks, Khadija, for the great work. So the legal translation is one of the critical mission tasks where the large language models start to be doing something sensitive in our life. So have you considered this when you come to do the evaluation? Because perhaps you and I may not be able to interpret a legal document properly, you know. If you think about something like patent or all these kind of things, it has the implication of the comma and full stop and the semicolon. Do you look at the fine-grained details on these things? So how do you consider when you go to things like the legal domain?
Can you just
For the
repeat that
evaluation
next
part. Yes, for the evaluation part of the legal, have you get some expert from those who work on the legal domain about, you know, the level of the translation, not just, you know, metric, the, you know, word orator, blue score, or any of these things?
Yes. So if you can see from the third step, the translations are submitted for a legal expert.
Right.
So that's why because I am not a legal expert, and that's why this data is being validated by a research group at the University of Law in Qadiyat University.
Okay.
Last question by Mustafa.
Yeah. So regarding the prompts, so it's not fair just to judge, I guess that's my comment, and the question also. To judge these large language models by only one prompt. So you need a variety of prompts in order to see whether how much was sensitive. And plus, this problem, in my opinion, it has two dimensions of complexity: being domain specific and being country specific, which means specific to a legal system. You know, we call it المحكمة الدستورية, or we call it المحكمة العليا, and so on. So in my opinion, also, if you consider in context learning, have you planned or tried to do in context learning for this kind of?
Now we are doing me and my colleague in our lab, we are starting we are starting our experiment with the in context learning.
And cross multi-country legal systems?
We are still we are still planning the methodology of how we can approach this this study. But thank you for your remark. I will consider them.
Thank you, Khadija.
Thank you.
So our next talk will be presented by Ahmed Shangiti, Arabic automatic story generation with large language models.
All right. Assalamu alaikum, everyone. Good morning. My name is Ahmed Omar Shanqiti, and I'm super excited to be here today to present to you our work on Arabic automatic story generation with large language models, right? This is a joint work with Dr. Fakhruddin Al-Wajih and Dr. Muhammad Abdul Majid. So this is our today's agenda. We will start with a brief introduction, a motivation. We will talk about the data sets that used in this work. We will talk about the prompt design, the experiments that we have designed, the evaluation methodology, the results, and if the time allows, we will show you some examples, and we will conclude with a conclusion, right? So storytelling is a human skill for transmitting knowledge and values and inheriting culture among societies. It has a wide variety of applications ranging from education, entertainment, gaming, cognitive, and literacy development, right? So our objective here is to develop large language models, or by today's standards are not very large, to generate Arabic stories in a variety of Arabic dialects, right? MSA and Egyptian and Moroccan view. Okay, so the motivation behind our work is there have been significant progress in English story generation, and also in multiple modalities, not only text or text and visual storytelling, right? But for the case of Arabic and among other languages, this research is still limited in amount of available research and data availability, right? So our goal is to shed the light on Arabic story generation and enhance the Arabic language models for story generation with the help of translated data and synthetic data sets, right? So for this work, we use two types of data sets. We use a translated data from an English source called Tiny Stories, we translated about 1 million samples of these data sets using Google Translate, and we applied some sophisticated filtering strategies to make sure that we have only high quality samples, right? And we ended up with about 500,000 samples, right? The second data set that we have used here is a synthesized data set that we created with a custom prompt and in 3 Arabic varieties, MSA, Egyptian, and Moroccan. And the reason for to have only 3 varieties is that when we prompted the state-of-the-art language models like GPT-4, it wasn't able to generate beyond those varieties. So we ended up using only those 3 varieties, right? And we created 1,000 samples in each of those. So the prompt design. So when we were experimenting with different prompt choices, we have different choices. For instance, prompting GPT-4 in English or in Arabic or in the corresponding variety dialects, Egyptian and Moroccan. But when we compared them using a pilot investigation, we didn't find that critical difference when we use English versus Arabic or Arabic versus dialects or prompt. So it makes sense to us to use the corresponding variety for the dialect itself, right? So MSA prompt when we want to generate an MSA story, and the same goes for the other varieties, right? So for the prompt, we have designed a set of 12 features with a probability of appearance P. Those features are age, place, story of end of story, dialogue, and so on. And also we made sure that this will be a country specific. So we designed an additional feature called country that spans across the Arabic countries, right? And when we what we mean by probability of appearance, meaning that the prompt doesn't have to have all the entire features. For instance, prompt P1 might have only 3 features of those, right? Prompt P5 might have 3 or 10 or so on, right? And this is to ensure the variety and the quality of generated stories, and that it's also well suited for the Arabic context. So the experiments, we designed 2 sets of experiments. The first experiment is taking ARA-Llama 2 base model, 7 billion, and fine-tune it only on synthesized data sets. That's the data set that we have synthesized using GPT-4. That's the first experiment. For the second experiment, we fine-tune on both data sets, initially on the translated data set and then on the synthesized data sets. And we call model from experiment 1, model A, and model from experiment 2, model B, right? And the configuration, we load the model in a 4-bit quantization precision, and we efficiently fine-tune our models with a QLARA, right? And the training took about 5.5 hours on A100 GPU with 40 gigabytes of VRAM. For experiment 2, it's the same configuration as experiment 1, and the only difference is the extra fine-tuning on the translated dataset. The training time took about 17.5 hours and on the same GPU, right? So the evaluation, we have designed 2 sets of evaluation. First is automatic evaluation with GPT-4 as a judge, which has been like widely adopted for languages such as English, right? And the other set of evaluation is using human native Arabic speakers for a human evaluation, right? And we compared our models against bigger and equally sized models. Namely, we compared against the ChatGPT, Command R 35 billion from Cohere, and SGPT 7 billion. So those are the different criteria that we have used to rate our models for both the human and the automatic evaluation. Those are fluency, coherence, instruction following, consistency, and the variety metric, right? So the reason we have added variety is that when we prompted GPT-4 to generate give us a scoring, we conducted a pilot investigation to see how those scoring is look like, right? And we have found that those scores are very preferring MSA content instead, even if the task is to generate dialectal content. So we explicitly ask it to give us a variety metric that's saying how well is the generated story is following the style of the required variety, right? And how we prompt it is like very easy. We just very straightforward way. We give up GPT-4 a prompt saying, hey, GPT, you are an expert in Arabic storytelling, and we are going to give you a story generated by a student alongside its prompts. And we want you to give us a scores out of 5 for the following criterion, right? And we give it to return to us only the scores, and we compute it automatically, right? For the human evaluation, we asked native speakers. We gave them 10 stories alongside their corresponding stories and the different models that we have used, right? And we asked them to do a ranking based on the fluency, instruction following, and the adherence to the required variety, right? And the process is just side-by-side comparison ranking. This is it. So for the human evaluation, again, for MSA, we included all models because all models succeeded to generate content in MSA. While for the dialectal evaluation, we focused only on 3 models, our model, 2 models, and the command R. And the reason for that is that ChatGPT and SGPT failed to generate a dialectal content. So it doesn't make any sense for us to include them into the human evaluation comparison. So the results shows that our model A almost always outperforms ChatGPT, and it's a bit lower of compared to command R, always performing better than SGPT, and almost always better than our model B. So for the dialects, model command R obviously outperforming the models, right? That makes sense because it's 35 billion, and it's also has seen more data than ours, right? So the evaluation demonstrates that the models A and B, ours are competitive with large models despite being an order of magnitude smaller. So the results of GPT-4 as a judge shows comparable results across models and also across varieties, with command R being slightly better than our models, and also we consider a direct like a drop in the metrics when it comes to the varieties other than MSA. So those are a few examples. I will go through them, some of them. اكتب قصة قصيرة this is for MSA تكون مفهومة للأطفال في عمر 8 إلى 5 أعوام. نهاية القصة يجب أن تكون حزينة، يجب أن يكون هناك حوار. عدد الشخصيات في القصة يجب أن يكون 1. We'll see how the model will go with this. So the story في قرية صغيرة في فلسطين كان يعيش طفل صغير يدعى ياسين كان يحب اللعب الرياضة كثيرا، وكان لديه حلم كبير وأن يصبح أفضل لاعب كرة قدم في القرية. كل يوم بعد المدرسة كان ياسين يذهب إلى الملعب حيث يلعب مع الأصدقاء. ذات يوم قرر ياسين يشارك في مباراة كبيرة بين فرق القريات. كان الجميع متحمسا ومتشوقا للمباراة، لكن ياسين كان يشعر بالحزن لأنه لم يكن يستطيع اللعب مع فريقه المفضل. So yeah, here the interesting part is that saying here, we ask it to have a dialogue, and the characters are only ones. So the model did a dialogue with it, with the one character with itself. So we will skip those. So the conclusion and the future works. Here we presented the first LLM based study on Arabic automatic story generation, which targets the MSA into Arabic varieties. We translated and generated data sets for our work. We fine-tuned 7 billion models. We compared our models against equally and bigger size models. We conducted an extensive automatic and human evaluations, right? The empirical evaluation demonstrated our model superiority to strong baselines. In the future plans, we plan to fine-tune bigger models on larger data sets and include more dialects in training for wider coverage. So yeah, happy to take questions. Yeah, please.
Questions?
Thank you for a very interesting talk. I have so many questions. I'll just try to keep them brief as much as possible. So I just want to get your thought about using an LLM like Command R and GPT-4 as judges, because I didn't see the human evaluation. I think what you listed there was
yeah, I go yeah. So those are the human evaluation results.
Okay.
Yeah.
I mean, I'm because I would like to see how it compares to humatic evaluation, because if they're not doing well on the task, will they be able to judge properly or not? This is something that I don't know the answer for. So maybe if you have thoughts.
Yeah.
And and the second thing is, if you take any of these other models, like let's say ASGPT or another, or maybe Llama 3 or something like that, and do the same fine tuning like that you've done on RLLM, how do you foresee that the results will be for those other models?
Yeah, great question. Thanks you. Thank you. So for the first question regarding the evaluation performance of GPT-4, right? Is that it? Yeah. So we conducted a pilot investigations into the terms of how the scoring is actually reflecting the true performance of the evaluated stories. So we find that the general performance correlates with the human evaluation, but we find that GPT-4 prefers MSA content, even if the task is to generate dialectal ones. So that's why we added an etc layer of, or etc metric called variety, which explicitly prompts the GPT-4 to give us to look into the considered variety, right? So, sure.
Does semantic evaluation using LLM correlate to human evaluation?
From the pilot investigation, meaning just looking into them, not in an extensive way, right? We need to do an extensive investigations more, but like in a lightweight, yes, it does. Yeah. Second question regarding the fine-tuning other models. Actually, the reason we took RLLama specifically is that we did a comparison with the base models and others before fine-tuning, and we find that RLLama actually is better in following our instructions in Arabic, so we decided to continue with it for the task. Yeah.
Okay, thank you. So not a questions, but I want to take like feedback from you. I have experienced like SFT many times doing many experiments in Arabic for different tasks. The main issue I have noticed or I have experienced with it is it's memorizing memorizing only, not be able to generate or to give like learning from the data, then generates different topics or different things or out of the data that is trained on. So have you experienced this this point? And have you also like tested this on different data set, different prompts, not in the data sets?
Yeah, great question. So actually the issue of, so those large language models have a huge capacity in their models. That means the capacity to memorize data sets, right? And actually that's an issue, especially that our data set by today's standards is a small data set, but we haven't actually seen a clear indication of overfitting or memorizing those models on our training data sets, because we were using an early stopping. So we think that's good for training. Yeah, actually there are like extensive details on the paper. Yeah.
Thank you for the talk. So there are two questions on Zoom. One is, have you done any analysis about the gender, political, or religious biases in the story generation?
Great. Actually, that's one of the limitations of our work. We haven't looked into the other than the pilot investigations on the generated stories, but actually we leave that for a future work.
Okay.
Yeah.
The second question is, have you considered giving the human evaluators the output of the different LLMs and then asking them to tell which is which?
Yeah. No. Actually, that's for the human evaluation. We unanimously give them different models, 5 models for the MSA configuration comparison, and the 3 models for the dialectal ones. Actually, we'll give them unanimously. We give them the prompt and the corresponding stories generated by model 1, model 2, model 3, and so on, without telling which is which. And we ask them to do the ranking, and then we. Yeah.
So I have a quick question about the evaluation of the story generation task. I think it's not a trivial task because it has not only one dimension, but many dimensions, like whether the story is coherent or not, whether it covers the intended purpose of the prompt. So we have many dimensions. How do you measure this?
So actually, we find it difficulty to evaluate all of them at once. So we asked our human evaluators to look into the following criteria: fluency, instruction following, adherence to required variety. But we asked them to put more weight on the adherence to the required variety, because we noticed that some models fail to generate even the dialectal content. So it doesn't make any sense to even if the model is generating well in MSA, but with the required task is to generate an Egyptian one. So that's actually out of context already. So we asked them to put more weight on their adherence on required variety.
Thank you, Ahmed. This is the end of this session. I would like to thank Nizar, Huda, and all the organizers. Thank you.
Thank you. Thank you, everybody. We're very sorry about being late. I'm partly responsible in the delays that comes in. We're about 8 minutes behind. We'll give the credit to everybody when they start counting. I give it now to the next session chair, Salim Mustafa.
Thank you.
Where is the speaker?
Thank you. So let's start the third session of our conference, the multimodality session. I didn't see the speaker. So our first presentation is entitled AREEj Cross-Lingual Learning for Effective Arabic Image Retrieval, and it will be presented by Imad Al-Afyouni.
Okay, thank you, everyone. Thank you for attending. So yes, my name is Imad Al-Afyouni. I'm going to present today our paper called AREEj, which is based on cross-lingual learning. Sorry, I'm a bit sick. For effective Arabic image retrieval. So this work is done at the University of Sharjah, and these are our co-authors, and we're happy to share our findings today. So our outline is going to be a little bit on the background, motivation of the research, literature review, our contribution, samples of the data sets that are used and published, and our model experiments and results. So what's the motivation behind this? So the motivation, again, as the session starts, is the multimodality, right? So multimodality with the generative AI, now, again, it's getting a lot of hype. But again, when we talk about multimodality, one of the main modality is text to image and image to text retrieval, right? And then also text to image generation and image to text generation and image to text generation as well. So which is image captioning. So we thought that I mean, text-to-image synergy is really, really important. So we want people to talk in usually, and then to retrieve images. And then when we started looking at the current models, again, we found very interesting models that are actually based mainly on the CLIP model. We'll talk about it. And they're actually performing very well, especially in the English language. As usual, we found that there is a gap in the Arabic language. So we wanted actually to discover more what's happening with the Arabic. So we wanted to test a lot of models, and we tested even multilingual models. We found that there is really some language barrier, and that image-to-text synergy is not as good in the Arabic context. So we are not able really to discover the Arabic contextual and cultural nuances that we actually wanted to see when we talk to that AI assistant that actually retrieves the images properly. So we found that there is an opportunity to extend such models and techniques to capture the Arabic's unique visual and textual constructs. So here we start. So we started by thinking, okay, again, we have a problem. So the problem is that we don't have, as usual, large data sets that is actually, that is the pair of image versus captions that is well done in Arabic. We have a lot of data that is happening at the English level. So we have people who have actually trained on gigabytes and gigabytes of data, a lot of data that's actually coming from the English perspective. On the Arabic domain, on the other side, the only one that actually we started building a few years ago was actually on the image captioning model, where we built
something based on MS COCO. Dataset was 123K pairs of image versus text. But then we thought that actually this is not also enough. So we started actually translating a bigger amount of data. So we mentioned the names of all the data sets that we have actually used and translated using the Helsinki NLP. We've tested also several translators. We are pushing everything online. Everything is published online. You can see even the translated data set, 13 million data sets, pairs of caption image is actually published with all the corresponding actually code, and everything is available there. And then also we had manually annotated XTD 1K for testing purposes, and that was actually manually verified by experts so that we can actually test it on real different data sets as well. So we used 12.5 million caption image pair translated, plus the MS COCO that is also 123K, plus again some testing data sets with XTD 1K pairs. Then on top of that, we built the AREEj, which is the first Arabic-focused text image retrieval model using the clip and knowledge distillation, which is the teacher-student learning model. We'll talk about it again. Overall, we achieved around 10% improvement over the multilingual models, not the English models, the multilingual models that are available right now in terms of MRR and recall metrics. And also we offered an online tool that is available again on the hacking phase. We have everything available. We have the code, we have everything, the models, that the translated data sets, and the tool itself for testing purposes available as well online for public use. So again, literature review, CLIP has been actually a breakthrough on that learning visual concepts from natural language supervision. We actually learned from, again, previous models that were actually being built based, again, on different languages. So we had CLIP Italian, CLIP Swedish, which is a cross-lingual CLIP. Again, they're based on Italian and Swedish languages only. And we have also one M-CLIP, which is the multilingual CLIP, that is actually also a state-of-the-art in that regard. They're also, again, most likely they're using similar techniques in terms of cross-modality with knowledge distillation to achieve, again, the state-of-the-art in terms of multilingual image text retrieval. But again, we thought that actually we wanted something that's purely Arabic. So we thought this has to be done based on, again, Arabic-focused embedding models. So we went again further. We have used such data, so data sets and everything available, as I said, so you can actually go ahead and check what we have used and translated and annotated as data. Then, of course, we went through a lot of data pre-processing because we wanted to, again, remove all the harakat, everything that is related to a lot of captions that are actually auto-generated that has some repetitions, a lot of things that actually could, again, add noise to the existing data set. So we tried to do a lot of automated data processing so that we could remove a lot of the noise, okay? So again, the methodology. So we leveraged the transformative clip architecture as our foundation, and then we employed the knowledge distillation technique. So the knowledge distillation is actually very famous technique in such way that you can actually transfer knowledge from the teacher model, which is the English model, to the student model, which is our Arabic model. So the idea was actually, with the knowledge destination, is that we do not want to do a lot of computational processing on the image part, because we thought that actually the image part is well done with the clip. So the clip and the multilingual clip, they are actually built very, very well in terms of pairing the English plus English versus images. So we wanted actually to work purely on the NLP part so that we can actually learn from the English language and transfer it to the Arabic language so that we can pair it again to the image encoder. Again, we chose the teacher learning approach over the contrastive learning. Contrastive learning, on the other side, is much higher computational cost, and usually it also works on minimizing the error between pairs, but it has actually a lot of peer-to-peer computational costs. It's much higher computational cost. So, okay, so we talked about the teacher student learning model. So we eliminated the need for direct image involvement, as I said, in training, so that we can significantly reduce the computational resources. The core training, the objective of the AREEj is to maximize the cosine similarity and minimize the mean square error, the MSE, between embeddings from the English model and the Arabic counterpart. So that's the original clip, how it works usually. So we have the English clip again. We have the image encoder and the textual encoder. They are actually again trained on millions and millions of data, and usually they are actually well trained, and we got tested up to cosine similarity of 0.9. So we wanted actually to transfer that good similarity to our Arabic focus clip. So what we did again, so this is our main focus here. So we translated again that data sets that's actually around 12.5 million. Then we do the post-processing and cleaning. Then that translated data set, it goes into multiple types of encoders, the Arabic focused encoders based on BERT mainly. And then I'll show you also this list of all the encoders that we've tested. And then again, the resulted embeddings were actually tested in the knowledge distillation technique by going again teacher learning very different times, so that we can again maximize the cosine similarity and minimize the MSE errors to achieve the best results. After training, and I'll show you also the experiments, we actually reached 0.86 cosine similarity on average, which is something that we had actually been, very satisfied with. So as a qualitative evaluation, the MRR metrics, which is again the mean reciprocal rank, which means usually we have MRR 1, the top 1, top 5, and top 10 images retrieved based on some caption that we actually ask for. So the MRR usually is actually again well-known metrics used in that context. We actually are comparing here our models that we have tested. We've tested actually ARABERT and RBERT and ARBERT, and then other models. And we are actually showing here the best ones that are performing from our counterpart, which is the XLM Roberta, which is the state of the art in the multilingual clip. Okay, 2 minutes, thank you. Okay, that's too little. So that again, our work based on the ARABERT V2 base, which is again based on the 512 2M. This is actually most likely with the one that is actually we added the MS Coco on top. These two are performing best actually, and then you can see also that difference with the XLM Roberta Large, which is actually a very large model as well, and you can see that actually most of our metrics, all of them actually are performing better. That's in terms of MRR, in terms of recall as well. You can see, so the recall is the it's similar somehow to MRR, but it gives you the frequency or the ratio of how much you are actually getting better in terms of again top 1, top 5, and top 10. You get some qualitative evaluation. So in the qualitative evaluation, we have tested on several strategy. So we wanted something that's easy, medium, and very complex in terms of morphology, in terms of context, in terms of semantics. So you can see also the different strategy that we've seen on that we've actually mentioned in our paper. You can also
So what we try to do is we try to repurpose an existing data set that we can then leverage for this particular task. And Ahmed is here. So he created the Qasr data set, and I think Hamdi as well, both of you. Yes, I see you. Yes. So we sort of repurposed that data set. It's a sizable data set. I think it's 2,000 hours of speech. It was created originally. Thank you, Nizar. It was created originally for automatic speech recognition. So it has some background noise and whatnot. So we kind of cleaned that and we used this. We used it for this purpose. Again, I'll try to be very brief. Let me move this a little bit. Okay. So we kind of like do this zero-shot work for Arabic, and we have the data set, the Qasr data set. We clean it a little bit, and by cleaning here, what I mean is remove samples that has noise that we think will kind of make it hard to use the data set for this particular task, right? And then we sample, for particular speakers that we take, and then we are going eventually to test the model on. So from 2,000 hours of speech, we go to about 272 hours. And from that 1.6 million, we go to about 400,000 cleaned samples. One thing we wanted to do is we said, okay, so I mean, there are lots of dialects there. And one thing that we did is like we just run a text-based system that does dialect identification to tell us which dialects are involved. And so we would say, okay, if the model says this is Egyptian Arabic based on the text, then we assume that the speech was Egyptian Arabic, kind of like a reasonable assumption to have. And this model also does some mistakes, but okay, so we kind of like take data that represents eight of the dialects and use it eventually. And I'll tell you how we use it. But basically our test, we're going to take 31 speakers from the curated Qasr data set. And we also have another data set in-house. So we could take like 25 samples from it, or 25 samples, meaning like data for 25 speakers, and we are going to test the system on. This is the architecture and kind of like the different stages of the modeling and whatnot. There is this XTTS system that already exists that does this zero-shot text-to-speech. And there are 3 stages involved. In stage 1, there is, so there is the input speech that goes through vector quantized variational autoencoder. So if you're familiar with a variational autoencoder, you have like some sort of a continuous signal that goes through the model that gets corrupted, and then you force the model to output the signal again, kind of like, what was the original input, except that here we're going to try to force the model to give us not continuous signal, but quantized discrete signal. So this is like the vector quantization part of it. So the speech goes in, and then the discrete signal comes out. And then the other thing we do is, and this is what you see here on the left-hand side. So the reference speaker. So we take like half a minute, for example, from a speaker. We embed the speaker, and that would go as input to the system. And then we want the system to give us speech that represents, like, that looks like that speaker. Okay. And one thing we do is like we condition on the dialect as well. So if we know that, I told you already about the dialect, if we know this is like Moroccan Arabic, then we condition on that. So we build a system with and without that dialect token. Of course, we're doing text-to-speech, so you have kind of to input the text, you represent it somehow, goes through this tokenizer and whatnot. And then all of this goes through the VQA, the VQVA. So you get like some discrete audio tokens. Finally, this will go through a HiFi again, a high fidelity generative adversarial network, and that is the one that is going to give us the speech output. Okay, I mean, if you're interested in this, take a look at all these different works and so on, and they are not things that we have created. We're just using something off the shelf to kind of do this as a first look at this problem. Lots of things involved, but from here, basically the important thing is like, what are the metrics that we use to see if this system does well and so on. So there is like mean opinion score, word error rate, and I think like, some sort of a semantic similarity based metric, which is this sex thing. Yeah, basically, if you look at these two tables of results, what we're finding here is that, so we have a base model that we don't do anything related to this dialect token conditioning and so on. And then the results and the bottom here below the baseline is where we do that dialect conditioning, and we see that it actually kind of helps a little bit. But it doesn't help necessarily across the boards, because remember we have two data sets, one from Qasr and one from in-house data, and we don't get like systematically improvement, output, improved output when we embed the dialect in both of them. So there is something else that we need to look at, and we haven't done really this. This is basically it. So there's nothing fancy, nothing more than this. And I think, basically we've kind of repurposed the data set. We kind of thought about this dialect labels idea. We've fine-tuned models. We have some basic, baseline. And it seems like there is a lot more work to be done on this problem. I'm done.
Thank you. Questions in the room?
Thanks for the presentation.
Yeah.
Maybe I've missed the point when it comes to the difference between the two data sets, but the word error rate is actually, like, the differences in the values are quite huge, at least to me. So could you please comment on maybe what's the reason for that?
Yeah, I didn't talk much about the in-house data set, which is a sort of from a different, I think the Qasr data set is from like, live conversations between different people and so on. So the in-house data set is coming from some, TV series that, would have different actors. And so it's just kind of scripted as well. But the two are different, the two data sets. There are lots of differences when it comes to the background noise, which we try to remove, yes, but still there are lots of differences. There are also, if you think about, data sets taken from Al Jazeera, for example, I mean, there would be lots of speakers, but, there would be also repetition. The same speaker can be, in more than one of these sessions and so on. So I don't know. So the answer to your question is, I think that needs more time and thinking and so on. And it also needs an error analysis to just like figure out exactly what is going on. There are also other challenges that I can talk about, but I don't have enough time. Yeah.
Okay, question here. Please go back here. I'm here.
Yes, I see you.
Okay,
Yeah.
my name is Ahmed. Okay.
I tried to look in two places at the same time.
Okay.
Yeah.
No worries. If you please could go back to the results. Here I'm confused. You mentioned that you fine-tuned the XTTS model with a dialect token, and here the results with dialect token, it's worse in both. I didn't get why it's worse after fine-tuning with the dialect token.
So we did a lot of things that I'm not showing on the slides, and actually some of the things we did are not even on the paper as well. I mean, there's one simple idea, which is, if you know the I think this is similar a little bit to the work that Bashar has presented in the morning. If you condition on the dialect, you get something, out of that for a different downstream task, that you're performing. So the idea here is like, if we embed the dialect into the system, would that help us kind of have a high fidelity speech and so on, right? Because I mean, like here, if you know about Arabic dialects, there are particular sounds that are sort of like distributed differently from, the same comparative sounds in other dialects and so on. So that's the kind of like the basic idea. But the results are not consistent. I agree with you, and that's also related to that.
Maybe because the tokens, you classified your data text-based, maybe that one of the reasons.
I think this is, yeah, there's definitely some noise coming from the dialect ID system because it's not a perfect system. There could be other sorts of reasons, I think.
Thank you.
But that's a good question. Thank you. And also, Amr's question is a good question. I thought you were going to ask me about dialect ID, but you didn't. Okay.
Okay. Okay.
I'm good.
Okay. So next speaker, please.
Yeah. You will help with the next speaker. How do we do this? Stop sharing. Yes.
This one.
The next paper is interesting, so you don't want to miss it. Lots of people leaving.
I think it's done the sharing. Yeah, the chair. It's okay. You see that the screen it's sharing.
It's fine.
Yeah, it's fine. Yeah. Okay, so let's start the last presentation. It's entitled Kalam, a multimodal LLM for Arabic optical character and handwriting recognition. This paper will be presenting by Gagan Batia. Thank you.
Good afternoon. Thank you so much for pronouncing my name right. That was great, man. Yeah, because I know that G doesn't exist in Arabic, so I really appreciate that. Hi everyone. So this paper is called Kalam, a multimodal LM for Arabic OCR and handwriting recognition. And so what we'll be basically focusing on is that our model can also understand Arabic, or like Arabic written Arabic in text format, and also in like handwritten Arabic, which also comes from like people who have written them with like pen, with like a blue pen, or like with like a black pen, on also annotated with like on iPad as well. And we also focus on historical documents as well, which actually focuses on a lot of olden documents which cannot really be like binarized because they are really too old. And we also focus on both of these as well. So we introduce a model that can perform OCR and handwriting recognition. So our main contributions is that we introduce a multimodal model, which is a vision encoder decoder model, which uses OCR and which also which can perform handwriting recognition. So we achieve like state-of-the-art results on handwriting recognition and OCR as well. We've trained our vision encoder on 4.5 million images, and we have also trained, and we have further fine-tuned it on 60K synthetic image and text pairs, and which leads to like the model also excels in further recognizing Arabic diacritics, and also is also able to process high resolution inputs. And finally, we've also introduced a high quality benchmark as well to evaluate these models and to further analyze and explain why our models are really good. So one of the main problems in this, like why we actually talk about this, is that Arabic script is actually very difficult to recognize for models, because there are diacritics or ligatures, and there are also many different kinds of ways to write the same or like the same select word. As we see here, in different fonts, the same word looks significantly different, which means that even though it's the same word, but it can actually be represented very differently in just different fonts as well. And this problem becomes very, very difficult when we look at handwriting recognition, because a lot of people do write it very cursively, which means that dots basically become lines, and they're very difficult to recognize because a lot of the dots and a lot of the lines are very connected. So this makes it quite a complex problem. And as we see, like OCR is one of the oldest problems that has been studied in like machine learning and in computer vision as well. But we would like to take it a step forward and then actually introduce this to the Arabic script here as well. So firstly, we introduced the Midad benchmark, which has like word based, which has like basically like sentence based, and we also focus on just single character recognition as well. And so these are a few examples of like the data sets that we have covered, and few examples of different kinds of data sets, and like examples of how we have like different like Persian data sets and Arabic data sets that we have also covered. Just like some statistics about like our different data sets. We have also introduced Persian and Arabic data sets. So this can cover like all. So our system would work for all different types of languages in that cover that use the Arabic script. So we actually performed this method in a very methodical way. So first we wanted to find which is the best encovision encoder that can do this, and then we have also want to find the best decoder, and then we have also performed a very significant error analysis to identify what works and what does not work. So firstly we identified that like which encoder works best, and we realized that DIT is one of the best encoders for this problem. And then we actually used DIT to find which decoder works best, and we identified that our BERT works really well here as well. But then we actually realized that there are a few issues as well to if you want to scale it to a production level system. And one of the main problems is that for like if you use most of the vision encoders tend to use a smaller resolution size. And since we wanted to expand the resolution size, especially for OCR and handwriting recognition, we need a higher resolution input, which is why we expanded the resolution input from 224 to 1024, which makes sure that like a lot of these details which are very intricate are visible and are very clear to the model. At the same time, a lot of the decoder models often use a word piece tokenizer, which sometimes not give us the exact output as we would expect. Hence to use that, we have also used like a BP encoder, where we have trained an Arabic Roberta model that can perform this very efficiently. So here we represent our overall architecture, which is based on using a further pre-trained SWIN model and a further pre-trained Arabic Roberta model. I'm just quickly going to go over the enhancements that we did. So we trained our revision encoder using 4.5 million images from different sources, from using Arabic manuscripts and Arabic books for training as well. At the same time, we also further pre-trained our Arabic Roberta model to further enhance the settings and the different settings for the models. And then one of the main things that we also did, we did a lot of data augmentation, where we take samples from like handwriting recognition, and then we use the same text and generate them in multiple different fonts to further enhance the ability of the handwriting recognition, because there is a limited samples available for handwriting recognition, and by training the model on different fonts, we can significantly enhance the performance on handwriting recognition as well. So finally, we see that our model significantly exceeds all the previous state-of-the-art models and all the basic models as well. And so we see that our model outperforms all the models. And here we've represented the WER scores, and we receive a very low WER score, which means that our model is very significant and very powerful as well. But in order to actually expand our model and to see, we've also introduced two data sets, which are called which we call in the wild Arabic data sets. So these data sets the model has never seen before. The model has not seen examples like these before as well. So we evaluate on these data sets as well, and these are significantly more complicated than and these are very close to the real time usage as well. And we see that our model is still quite competitive on these data sets, even though these model data sets are quite complex. And so these are just some examples of a real-time demo. So like this is one of the kind of like pictures that we have taken of somebody's handwriting, like handwriting that we have put up. And so our model is able to recognize it correctly as well. And similarly, this is somebody's iPad, like somebody that they've written a word on iPad as well, and which the model is able to recognize. And similarly, these are like one more example. I'm not gonna embarrass myself by reading wrong Arabic, so I'm sorry about that. So these are a few examples of how our model works, and it's just straightforward, just image to text, and where we are able to perform significant handwriting recognition here as well. Thank you so much.
So thank you.
Thanks, Ivan, for the nice talk. I was just wondering, do you have an intuition of how much synthetic data helps? Like your synthetic data was only about 60K, I think, right?
Yes.
Like, if you increase it, does that help the system? Does it start hurting at some point because it's synthetic, or?
Synthetic data, so synthetic data does significantly help it, but we didn't really do any further analysis on how much does it help. But we did identify that it does significantly improve the performance on the from the baseline model. But like building more significant like synthetic data is a significant challenge as well, as it needs to be very close to how the real samples look like. So which we found to be a significant problem in, especially in like in the system, because a lot of the fonts look very different from what we are trying to do. So it's a little bit of a challenge to generate high quality synthetic data as well in this field.
Okay, last question.
Thanks actually for showing the work. So actually the examples, actually, thanks for showing the examples at the end. It doesn't look to be 1% toward the error rate.
These are like a little complicated examples.
So do you actually, this is brings to the second question. So do you have a link to the demo we can try? Actually, it might be a good way to collect data as well.
Yeah.
So give us GPU, we'll give you a live demo. But you know, definitely we can put a demo for 24 hours. The other question is, in fact, we added the data in the wild exactly for what you're asking about, just to show that the data sets that other people have built for this problem are not realistic. So we actually wanted to show that, okay, we get like below 1 where the error rate, but hey, like if you go to the, you know, that more complicated space, I think there will be more challenge.
Yeah.
Okay, yeah, thanks for demonstrating this.
I think let's continue this discussion in the break after, and we'll pass to Nizar.
Thank you, Salima. Thank you, Gagan, for keeping us on time too. Just before everybody leaves to the lunch break and the prayer break, just want to remind you at 1:15, please come back here. We're going to have a group photo near the end of it, closer to the beginning of the session. Let's all be present for the next session speakers. Also, just as a teaser, I'll give you the update on the SIGARAB report and the 6 events that are going to be happening within the next probably, well, before February. There's 6 Arabic related events. So if you want to hear more about it, come over. Thanks.
Thank you. Thanks so much.
to make sure it's not a free holiday. So. Thank you. So, you know, if you have some support to put into this, whether you bring data or you cover some of the travel, that will get it some momentum and initiative and serious to move forward. So, what to do next is press next, which I cannot do, or forward. He touched the computer. Okay, all right. Okay, I need your magic touch. And the blessing. All right. So what we have now, I'm very happy and excited to have some tentative buy-in from two exciting projects that I'm happy to see from the work has been done in Johns Hopkins, and hopefully we'll learn more about it. For everyone here, please come forward, propose a project for these 2 weeks, something that you are interested, you want to do, and you need support, you know, but also I would like to see some commitment from you as well. What is the commitment? It's up to you. It's an open call. Please let me know whether you do something with the legal or something with the image or something in the text-to-speech or dialect identification. We are open as long as we go to the scope of a speech plus multimodality. There's a great effort happening in winter school in text. So why do we go and compete with each other in this? Like, we don't all have to be camel tools, so we don't all have to be text tools. I cannot miss the opportunity. So let's focus on, you know, what can be done beyond the great effort has been done on text. So in terms of practicality, we are recruiting lectures. So if you think you can lecture us, you can cover one of the topics. The current theme that we have right now is going to be from 9 to 5. The first half of the day will be 2 lectures. The second half of the day will be practical lab for the lecture that has been taught, right? Propose the data, please. You know, if you want to do something, do some effort as well, and come with the data, come with a baseline, come for something to do. Reach out to help, because this is a sizable effort, and I would like to avoid the mistake that we always underestimate the effort and get stuck with things. So if you think you have what it takes to plan this and move forward, please let us know. Happy to say that we already have now a website with a barcode. How can I do this? Hide, blah. Right. Okay, good. So feel free to scan this. It will take you to the website where you can register, you know, put your information, put, you know, something about what you want to do. Please share it with your colleagues and friends. You know, I'll be grateful if you can be our voice and, you know, start to make the community aware of this. And this is an email where you can reach us to let us know how can you help and make this successful. With a bit of luck, would like to have this happening every year, but, you know, let us try with 1 year together and see how it goes. Thank you very much. Any questions? Yeah. Good. Right, excellent. So so we are targeting international, regional, and local. From the international, given the support that we'll have to do with limited support, the international would like to get those who are in the field, early career PhD students, those who are practitioners, those who are, you know, have been doing a lot of work with text and like to go to the multimodality, like to go to speech, like to go to image. From the professors, you know, those who can contribute. Regional would like to make the pool bigger a little bit. Those who are, you know, maybe undergrad. Local will be everybody, because I don't have to fund anyone. So if you'd like to take the bus and come here, would like to taxi and come here, please be my guest. We plan to book a place, the room that can take up to 200 people. So if I have, you know, second grade student who would come to do Python and impress us with something, you know, why not? So when I was thinking in a speech, actually, I tell you, when I was thinking in a speech until 2 weeks ago, I was thinking in 5 lectures, signal processing, speech recognition, text to speech, 2 days with advanced topics like audio LLM or something like, you know, the fancy topic that had been happening. So teach people the fundamentals and also work on practical things. Now we have multimodality. So I'd like to, instead of says, okay, guys, we're going to teach A, B, C, D. I think I'd like to leverage the great community that I'm speaking to. You guys come and says, why not to cover this topic? And jointly, within the next couple of weeks, we can balance between basic principles and, you know, the main downstream tasks for people can get something hands-on. Yep. Not yet.
The instructors. So there will be a professor who will be teaching. So I was talking to Sanjeev and colleagues in Johns Hopkins. Maybe we can get a professor who can teach us about basic signal processing and how speech recognition works. And meanwhile, there's one of the interesting tools that's coming along, such as K2, which is using one of the transducers and very elegant architecture. Ideally, we will have a PhD student, someone like our friend Amir, or some of our colleagues like many names, right, could come and have hands-on. So ideally, we'll have a mix between the two. Unfortunately, we don't have the budget to do for 6 weeks. We'd like to compress as much as we can within these 2 weeks.
But I have many contributions like ideas for workshop tutorials, many things related to this and inspiration to so can I, for example,
by all means, go to the registration page and share with us what would you like to teach us. Maybe somebody has built a very interesting framework and I'd like to get the community to adapt it. And ideally, we'll have some of our friends here, a small community, can filter the application and can see who can fit best. This is a voluntarily work. I mean, the more effort you can put it together, the better it is. I was talking to Ihsan a couple of weeks ago, talking about the tokenizer in Arabic. Tokenizer is an interesting deal happening. And now with multimodality, why not to have a session about the tokenizer? This hasn't been one of the things on our radar for a long time. And there is an ongoing discussion on bringing this to the community. And then, if I'll be super happy if we end out of this with a shared task on tokenizer in Arabic multimodal. I'm just making things up right now, but I think there are many people who will be interested in this. So yes, any ideas welcome. Yeah, please come, Sanjeev.
One of the people asked, who's the audience and all that. Maybe you should have asked a higher level question. Ahmed, why are you doing this? Right? So the thing is that I don't know if you guys feel this way, but we've noticed over time that our Johns Hopkins workshops had a great role in bringing the community together. Pretty much all the senior people in the field went through Hopkins one summer or the other over the last 25, 30 years. And we're thinking that the Arab world could benefit from maybe a smaller version of it by doing it for a few years in a row. We want that in 10 years from now, anybody in Arabic HLT has been to this winter school for 1 year sometime. And that way everybody's connected with each other. So we want to build the community.
Yes, we should be taking a group photo now. Thank you, Ahmed. Fantastic effort. Okay, so that's session number 4. We have 3 talks. As you see, the first one is multitask benchmark for assessing Arabic legal knowledge in large language models. And we have Faris presenting it. Okay, let's start.
All right, Bismillah. أولاً, Assalamu alaikum. My name is Faris Hijazi. Today, we're going to be presenting our work, Arab Legal Eval, a multitask benchmark for assessing Arabic legal knowledge in LLMs. So I'm sure everyone has at least worked a little bit with LLMs and would like a better or more concrete way to quantify their performance. Our paper is going to be discussing that. This is a joint research between Thiqa Company and KAUST, King Abdullah University for Science and Technology, and we're going to be having 2 main contributions. One is the benchmark dataset itself, which is a huge collection of questions and answers that will quantify and give an evaluation and somewhat a metric for the LLM performance. In this case, in the Arabic language and in the legal domain. So this is domain specific. The other thing is that the methodology that we use to create this data set. So these are applicable to any domain and any language, which is why the methodology is a contribution. We open source all our code and all our data, so feel free to check it. There will be a QR code at the very end. We'll be going over the introduction, current LLMs, why we decided to do this, why we decided to go with a benchmark, why we decided to go with legal, the legal landscape and the sources, the data sources, why we chose them, challenges with current LLMs, the data set and how it was created, and then excitingly results and comparing different LLMs. So why did we decide to go with this? Just like everyone, we decided to create our own LLM. So we head out and started testing different LLMs, different data sets, commercial, closed source, open source. And we realized quickly that it's actually not very easy to choose actually which one is performing better. We noticed recently with generative AI in general that it's a lot less about engineering and it's becoming a lot more about defining the problem. So it's getting a little bit fuzzy, which us engineers and scientists are not very comfortable with. So we always have to start by defining the problem and a metric that we're aiming for. So this is why we created a benchmark. And as many great scientists have mentioned, if you cannot measure it, you cannot improve it. So instead of investing our time into building an LLM, we invested time into creating a data set and benchmark. And why the legal domain? Well, it's promising. It was quite exciting seeing that the GPT-4 has passed the bar exam, although there are some skeptics because it's a very narrow domain exam. And then it's challenging and impactful. So hopefully solving it will actually improve people's lives. We're hoping that. In terms of related works, so this presentation, I'll just be talking about the data set, why we created it. I'm just going to try to give as much context as possible. As I mentioned, I already explained our work. We created a data set. And I'm going to be explaining how this is impactful for you and how you can benefit from this. So related works, this has been done in multiple languages. We have Legal Bench, which is a collection of 162 different tasks. Please do remember the name of this paper, Legal Bench. I will be referencing it many times. Most of these are closed set question answering, which means you either have a question or a document and a question, and then the answer is within a limited number of possible answers, like yes or no, relevant, not relevant. It's not free text output, which makes it very easy to evaluate. It's easy to regex yes or no. There's also the Mandarin and Chinese document equivalent, which is Law Bench. And then the Arabic MMLU actually has a subset of political and legal science, or sorry, legal and political science. Challenges with current Arabic LLMs, it's not a surprise that there are many dialects in the Arabic language, which creates different nuances according to different regions, different countries. And we have, Arabic is already not a very high resource language. In addition, anytime, whether it's Arabic or not, when we go into a specific domain, things get quite, the vocabulary can become quite scarce. All of the words already exist on the internet, but the usage of certain words within certain contexts, especially legal, becomes extremely scarce. So these base LLMs are not used to seeing these, which is one of the challenges. And then evaluation and measurement. This is not specific to Arabic or legal, just evaluating is difficult in general. All right, so going on, as we scour to find some data to create our benchmark, we are going to use open source public data and we scrape them. First, we consulted legal experts. What type of data is actually relevant? We want to kind of min-max or choose something that is low effort and extremely impactful. It turns out that within different domains, the top three are commercial law, public law, and civil law, which comprise of most law. I mean, you can imagine that commercial law is the majority. So based on this, we chose 2 data sources out of 38, which feed into these 3 domains, so just having these 2 data sources, which are raw documents, not questions and answers, just raw legislations and documents, will feed into this. Moving on, this is our distribution for our data set. We have these raw documents, and then we have a couple of other benchmarks, which we'll either translate or use as seed data to synthetically generate more data. So from this data, we created 3 different formats of questions. We have open-ended question answering, where the LLM can speak freely, which is harder to evaluate, and we'll get to that later. And then we have multiple choice questions, which you are all familiar with, such as MMLU, where you have to choose A, B, C. And then you have legal bench, which I have mentioned before, the English legal benchmark. We translate it, and we talk about how we do the translation. So experiment setup. You'll be noticing this pattern quite a lot. We start with having raw data. We do a lot of experiments. We do filtration. And to save effort, we can't filter every single example with legal experts. It'll be too expensive. That's why we create a funnel. First, we filter it automatically. We filter syntactically. We filter, and we just keep doing different prompting methods, this is all engineering, basically. I'm sure you're very familiar with the creating baselines. So we create multiple baselines, and we just perform evaluation on different baselines. And we end up with, at the very end, check with legal experts, and then we have our first part of our data set, which is the MCQs. We do prompt optimization during the inference time or during the benchmark time. No interesting insights here except two things. First of all, chain of thought in English has a much higher performance than in Arabic. Even though the input and the output that is expected is in Arabic, you can see on the right side that Arabic chain of thought performs worse. This is consistent across all models. In addition, this is also actually interesting. The few shot examples that we use to optimize different LLMs, of course, we optimize per LLM. And these few shot examples that give good results are consistent. The same few examples are consistent across every LLM, which just indicates that, yes, it's not LLM specific. Some examples just have very high signal. Moving on to our second task, which is the open-ended question answering. Once again, another funnel where we gather handwritten, frequently asked questions. We scrape these, and the work that we do is we compare them. We find raw documents that are the context for them. Here's an example, question, answer, context. And then we have the translated legal bench. This is our third task. These are closed set question answering. We choose data that is universal and not region specific, such as privacy policy. Am I allowed to use this data from the user? These are not specific to a specific country or specific language. And even when you translate them, it's not specific. We do a lot of work for translation. We evaluate using GPT-4, using AREEj score metrics, using legal experts to review, and consistently Opus machine translation achieves the best. So we use the Opus machine translation model to do the translation. This is the template that we use. Once again, English instructions, even though the content is in Arabic and the expected answer is in Arabic. Results, we do experimentation across multilingual and Arabic specific, as well as open source and closed source models. So first task, the MCQs, we, once again, multiple prompting methods, and it's not surprising that GPT-4o is performing the best. Few-shot is the best performer. And then we have our legal experts. We actually had a small, very, very small sample. So this is one of the things that need to be improved in the paper. We had an absolutely tiny sample. We took it to our legal experts and we compare them with the LLMs. So legal experts are 90%. Out of 100, and then you have the best LLM is around 80%. So it's reasonable to see this, that the experts, I mean, I'm hoping that the legal experts are going to be better. But the LLMs are not too far behind. And we also have to mention that these legal experts are not specialized in commercial law, which is most of our data. And then our second task is the open-ended question answering, which is difficult to evaluate because the LLM is free to continue speaking. So once again, and you've seen this today multiple times, we use GPT-4 as a judge or a strong LLM as a judge to give a rating given the ground truth answer. Is it matching or is it not matching? It's important to mention this, that LLM judges are biased towards their own answers. So what we have to do is, for example, use Cloud to evaluate GPT-4 and then GPT-4 to evaluate Cloud, just to make sure that we don't have any, bias. And here, these red lines are the legal experts, and they are not performing better than the best LLMs. But we believe this is because of the small sample size and because of that they are not specialized within the data domain that we have. So we can see GPT-4 is performing the best. Once again, not surprising. Running across different times. Actually, sometimes Cloud is the best, and some Cloud 3 Opus, and sometimes. I'm not going to go into every single detail. I'm just going to give you the observations that we have. That open source LLMs are not far behind. You can refer to the paper for more details. And then let's go to finally the translated legal bench. You can see that once again, open source models are not far behind. Usually Command R+ is the follow-up to GPT-4 in every single benchmark that we have. And here we can see that the LLMs are scarily close to our legal experts. Once again, it might be because they're not specialized within our domain data. Here are more details about each task. You can refer to the paper. Future work, as I mentioned before, we need to do more rigorous testing and more rigorous evaluation from legal experts that are actually specialized in the data that we're using. We should do more comprehensive runs across different LLMs. We did not get to run through every single LLM. And by the time we published the paper, new LLMs have come out, like Llama 3.1 and other ones. And granular categorization of the data. We would love to do this. So some of our data or some questions require more context. For example, if I say, how many years does it need, does a driving license expire in Saudi Arabia? I would not expect an LLM to know this. However, I would expect an LLM to be able to answer this given the context. So it would be really helpful to have such a metadata tag within every single question so that we can start filtering these and be fair. Because what we noticed, this is also very helpful for RAG evaluation. And in our open-ended question answering, what we do is we feed it once. Sorry, I have to go back to this. We feed it once with context and once without context. So this is actually half the amount of double the amount of the LLMs. And we thought with no context, it would not be able to answer at all, but we can see that it's actually very close, especially large models. They're able to answer without context at all. This data set specifically is also very helpful for evaluating the RAG itself, whether it's retrieving the correct context or not. And thank you very much for listening.
Thank you. Questions?
Guys, thank you for the presentation. If you go back for the results sections, the one before, I think. First of all, I am very happy to see the Arabian GPT model you used. Actually, I have worked on this model, yes. We have trained in Sultan University Virtual Lab. It is very small, and it is trained on news. Plus, it is only text generation foundation model. What actually we have done, other than this, we have a paper like for predictions of legal rulings using different large language models. And we have reached to, maybe similar conclusion. We have used the Moj data sets. So this is nice. What I am thinking of now is to use these data to train the Arabic models that we have, even the smaller, because what I experience is with the fine tuning, we are getting very, very good results. So I think next step we will use the data we have to fine tune maybe our Arabian GPT and then use your evaluation to see then the impact and maybe to get or to have like Arabic large language models working for this task. So thank you very much.
All right. First of all, thank you for the lovely question. Can I just know your name, please?
Omar.
Omar. أهلا وسهلا عمر. Okay, sorry. You have touched multiple subjects. I'm going to respond with the fine-tuning idea that yes, fine-tuning is important. However, it's still not clear whether it will increase the reasoning capability or not, or just make the LLM more comfortable with the vocabulary itself, which means there's a lot of work to be done there for domain-specific LLMs. I have not studied it well enough. I have not done enough literature review. The second thing is we imagine that the ideal system is something like just a really, really, really good LLM, general LLM with a good RAG. So a good RAG with a good LLM with some really good engineering around it. I'm personally and the team, we are imagining that would be the ideal system without needing to actually fine-tune it on legal documents, but it somehow should be aware of the vocabulary. So the only thing that needs updating is the vocabulary itself within these contexts, because as we mentioned in the beginning, the vocabulary is quite scarce within these contexts.
Okay, thank you. Any more questions? Yeah, maybe a last one.
Thanks again for the interesting work. Just one tiny question. In the tables where you showed actually the results plus the human versus the human. So you said the humans are on a tiny bit of the test data. So is the results down there is only in the same tiny bit or the same exact part?
It's a different slice of the data set because, it's a different task. But yes, extremely tiny.
The table be underneath the table, this one. Yeah. So these results here are...
All of them are... no, the table is not. The table is on the entire data.
So you cannot compare them?
No, I cannot compare.
So actually, it should be actually the same tiny bit to be sure, because
Absolutely
maybe you
correct.
get the easiest part. Actually, the humans are doing not great as well.
Yes, absolutely correct.
Okay.
So this is a limitation of the paper. And it's mentioned in if you read the paper, it is mentioned the limitations that we definitely need more expert review. So thank you for... To be honest, we weren't sure if we were going to have these experts actually get these responses or not. So when we actually did get these responses at the very last second, we just quickly put them together. And this is not even in the paper, the expert response. This is in the presentation. So it's just like a nice little cherry on top.
Okay, thank you.
Thank you so much. I'm happy to have a talk later.
Okay, so the next talk is benchmarking Llama 3 on Arabic language generation tasks. We have Mohammed Abdel Majid once again.
That's really my thing.
Okay.
Is that so?
Yeah, you have everything. No, just
Okay, thank you very much. Nice talk, yeah, Faris. I'm going to present this paper. This work has been led by my now previous student, Muhammad Tawkat Islam Kundakar, and in collaboration with 3 other people, Nu'man, Fatima, and Abdurrahim. And I am Muhammad Abdul Majid. Just like at a very high level, I mean, we did this work because we think it's important to understand, how these open source LLMs fare on Arabic, just to see where things are at. So this is sort of evaluation work, because, every few months there is a big model that is being released. And I think as a community, it's nice and important to understand where these models are at and their limitations, their, strengths and so on. So in this paper, I'm just gonna show you what we did, how we did it, and so on. And I'll also stay very high level, and I'll try to kind of get it done quickly. But this is a story, so that I just told you. So we basically evaluate Llama 3 70 billion, and now there is Llama 3.1, of course, as you know. This one, when it was out, people were very excited about it and so on. And we wanted to understand, how it fares on Arabic because of what Arabic is, right? So Arabic is a very, it's a collection of language varieties and dialects and even languages. You can talk about it as this as well. Very diverse. And it's important to evaluate it. In previous work, we have done quite some evaluations. So last year, we've done some evaluation on, some of these large language models like GPT-4, 3.5, BERT, and so on things like natural language understanding. So we kind of like have a feel of how these models fare on these NLU tasks. We also did some evaluation on machine translation, how these models can translate very well or not, given, for example, the history that Google has on machine translation. They have very powerful systems, historically, and poured a lot of money into it. So you would expect, so for example, a model such as BARD to do well on machine translation, except that it didn't at the time. Of course, Google has better models now, and I know Rami is now at Google, so I will stop there. The contributions of this work is, this is the first benchmarking of Llama 3 7 billion as far as I know on Arabic. So we do evaluation only on Arabic natural language generation. When we started this work, we wanted to do NLU and NLG, but we didn't have enough time and as many GPUs around at that time to do all of this. So we just stick to NLG. So we did quite some systematic evaluation on these NLG tasks, and we sort of found that, okay, Llama 3 70 billion is reasonable, but it's actually not as good as ChatGPT 3.5, for example, on Arabic NLG tasks. And actually, in particular on some dialects, when you try to do try to do machine translation involving some dialects, it's actually also inferior. Okay. I think that is the whole story. There isn't much more to say except that, okay, we picked 20 distinct natural language generation tasks from the Dolphin benchmark. These involve things like dialected translation, question answering, summarization, paraphrase, diacritization, and whatnot. And this is really coming from the papers that we had last year. So where we put these together, we have some sort of a prompt design where we ask the model to take a role. So for example, your role is a generative language model, and then take a task. Your task, let's say, to translate. I expect you to give me, an output in a target language. And sometimes if this is under few shot, then we give the model some examples, and then just the input to evaluate or to turn into a different language or whatever the task is. So this is the setup. And we basically do 0 shot, 3 shot, 5 shot, and we collected like a couple hundred samples from each of these tasks. And we sort of play with Llama 3, 70 billion, but then we also compare it to ChatGPT 3.5 as of that date, because these models keep changing. And we compare to a small fine-tuned model, the AREEj 5, which in our previous work found that it gives the state of the art on these tasks. Some hyperparameters here. Then basically what you see here, like maybe if you just look at the 3 things that we highlight. So this is Llama 3, 70 billion versus ChatGPT, that's like 3.5 versus the small model, which has AREEj 5. And basically what is highlighted is under 5 shot, and the AREEj 5 is just fine-tuned on 200 examples, just to keep it also kind of small size, because it wouldn't do well under 5 shots, for example. But just the fully fine-tuned one is in the last, or actually maybe the other way around. This is like AREEj 5 evaluated on the 200 examples, and the columns that's in gray is on the full test data. Anyway, so ChatGPT outperforms actually Llama 3, 70 billion, and the smaller fine-tuned model does much better, except that we find that for some tasks such as code switching, Llama 3 actually does reasonably well, because it's a multilingual model anyways. I mean, ChatGPT is also a multilingual model, but I don't know, for some reason, Llama 3 seems to be doing better on that task. The code switched machine translation. I think this needs some sort of an error analysis to just understand better what is going on here. So now for the performance on dialects or dialectal generation, so ChatGPT outperforms Llama 3 on MSA, and almost all like the dialects except Palestinian and Syrian. We think that okay, if you sort of like take more dialectal data and expose Llama 3 to it, maybe you will do better. And you close that gap with the 3.5 model. Just for a very quick thing, and I think tokenization was mentioned by Ahmed this morning, and it came along in some of the discussions earlier. Okay, Llama 3 has a better fertility rate for Arabic compared to Llama 2, for example. So it would sort of allow you to have wider context or longer context, when you work with Arabic. Of course, the dedicated model, the Arabic T5 model, it's just an Arabic model, so it has an even better fertility rate for Arabic. But this is just to say that Llama 3 is better than Llama 2 for Arabic, because of one of the reasons is that, right? I mean, I think it's better than Llama 2 for many other languages as well. Okay, I'm almost done here. Some limitations, so we could have like evaluated on more samples, but give us more GPU and we'll happily do it. We could also kind of like compare to many more models, also issues of GPU. I mean, this work takes a lot of GPU time, right? And if you have other projects going on and, you know, which student would have like more GPUs and who wouldn't, and these types of things. So also, I mean, it's not very clear. These models also, you would read the papers and you would say, okay, we have like, I don't know, 2% Arabic data, whatever. But you know, not necessarily that you know exactly what type of data, where it is coming from, the distribution of dialect versus MSA, the domains involved, what, like lots of questions that we really don't know. So I think evaluation gives you a feel of how the model behaves on a given language, and also like that, you know, related dialects and so on. This is, I think, my last slide for this. So, you know, some future work that we can talk about in the questions, but you know, there is a lot of space for improvement, you know, on all of this work, I think. That's it.
Great, thank you.
I'm also doing the next presentation, so I feel relaxed. So if we take more time, it's my own time. So,
which means I don't have to take extra pictures. Thank you for the presentation.
Yeah,
I have a quick question concerning evaluation specifically. When you take a data set and you fine tune a particular model on it, right? That model starts learning other parameters or other, you know, features of that data set. So you know, I'm just curious. I mean, like about fairness of comparison. So if you take, let's say, Llama 3, and take whatever number of examples you have in these data sets, and then fine tune Llama 3 on those. I know it's very expensive as far as GPU time, but do you think this would be a fairer, or do you think just not?
I'm trying to understand. No, I'm
okay.
trying to understand.
So basically, take Llama 3, take these 10 or 20 data sets that you have, fine tune Llama 3 specifically for them.
Except that we don't fine tune here. We just like do few shot learning.
I know you do. So I'm just in my head, I'm trying to figure out the fairness of the comparison.
Right.
So I just want to get your feedback.
Yeah, which is an important thing. The fairness is so you're saying if we take Llama 3 and fine tune it.
Yes. And compare it to RT5.
And compare it to RT5.
So now both of them are fine tuned.
Oh, I see. I see. It's a good question. I think so. In this work, we don't fine tune Llama 3 at all. This is a 70 billion model. I mean, okay, so we could fine tune it, but we don't. So that's number one. Number two, even if we fine tuned it, so you're saying, is it fair to compare it to a smaller model like RT5 under fine tuning condition? It's not fair because the sizes are different. It's very unfair, right? I think the only reason we put results of RT5 in the columns there or in the tables there is that, you know, you would still, so if you are a company and you're trying to do something and you come and I come to you and say, I want to do this, can you help me?
Sure.
Before you tell me that I will put an LLM on it, you should be able to tell me what happens if you just put a very small model.
Exactly.
You know,
yeah.
And can you still do well? Because, you know, there are issues related to production and cost and so on.
I mean, this is a very fine point. I mean, and I was not asking the question to.
It's just for discussion.
For discussion, because I mean the point that you make, that a smaller model that is heavily fine tuned might be sufficient for the task at hand, and we don't have to use like a bazooka to kill a fly, right?
Right. Yeah, and maybe it wasn't clear in from what I said, you know, why we are putting RT5. I'm sorry, I should have sort of like clarified this, but you know, there are of course other benefits you would get from the larger models. They would probably generalize well. So okay, if you take an Arabic T5 model and fine tune it on whatever label the data you have, and then what happens next year? So are you gonna, if you don't have more labeled data, then you know there is diachronic shift in the data. So meaning like if it is like news related task, then there are new named entities in the data, new events happening, and so on. And the static fine-tuned model is not really very good. I mean, I think the large language model also would suffer from the same problem, except that the large language model has a good ability to adapt itself under, let's say, few shot settings, for example. So, you know, in its capacity and its parameters, maybe it could. So I think we need to continuously be doing these types of evaluations, you know, over time and also over different types of domains.
Okay, so,
Yeah.
so I think the question took some time, so we need to go ahead with
Move on.
the next one. Yeah. So maybe we'll discuss the questions in the break. Okay. Thank you.
Okay. You can ask your question. I will adapt. Yeah, it's my time.
Yeah,
So,
as
yeah.
you guys, you can handle the time. Like,
Yeah,
finish
I will be able to handle the time. Go ahead. Yeah.
So the things is like quite similar to the things that he has been talking about. In ICL, I think because right now you are not doing like fine tuning, so it is like just inference, okay, few-shot learning. So I mean that in the case that we have a large parameters models, like for example MS-70. So why we don't know it, like we use like some small model as proxy. It's like there is a lot of folks that they are doing like retrieval demonstration. So I mean that, is there any evaluation in this term?
Okay, can you ask your question again?
The question is like, suppose that we have a big model, it's like 70. Can we use some models like as proxy models, small models? We just use these models to select some demonstration. Then the inference, the last inference step that we can use, is there any evaluation in this?
So, okay, so I think you can. There's nothing.
English, we don't have evaluation. So I mean, that is because I didn't attend the presentation. So I mean, this is a solution. Is there any evaluation of it or how this works?
like distillation or some routing?
Yeah, even like, for example, in the generated task, in future planning.
Yeah.
Not the number of shot is important, as the quality of the shot is important.
Well, the number of the shots, the quality of the shots, the order of the shots, the length of the shots, and I can give you 5 more reasons.
Totally
Yes.
agree.
Yeah.
That's what I mean. I mean that can we, if there is any evaluation that, okay, the time is time's up. Okay, sorry. Sorry. Thank you.
Yeah. Okay, but thank you very much. I'm going to move to the next presentation.
Yeah. So might have like, can you do it in 12 minutes or so?
I can do it in 12 minutes.
Okay, cool.
Because I love you, I can do it in 10 minutes.
Oh, hero.
Yeah. Yes. Yes. Yeah, this. Right. Can we refresh? How do we refresh? Like push enter, for example?
So you have like one copy.
Yeah. This one. It's still the old version, but I don't know.
From. Start with
From?
Okay, go down. This one. From mine.
Yeah. Okay, thank you, Dr. Shadi. And this is PDF, so maybe I should download it first. How do I do? Do you know? Okay, so the next paper is a machine translate. It's kind of talks about machine translation. We will share the screen. Yes, I'm just talking using the time until it is shared. So this paper is going to be about a machine translation system for Coptic, English, and Arabic. And I'm going now to motivate this work. Thank you so much. Okay, so this paper is in collaboration. So the student who's leading the paper is Muhammad Saeed, who couldn't be here. Yes, we should share the screen. Yes. Yeah. Right. No, it's good. Sure. Control L, and then I just need to hide this first. We're trying to make it full screen. It should work, but I don't see the menu. Okay, fine. Yeah, so this is work that's led by Mohammed Saeed, who is our student. So it's in collaboration with a couple other students of ours, Asim and Mukhtar, and I say ours because Professor Shadi, who's sitting in the first row here, is also a collaborator in this paper. I mean, this is also very, very simple work. The idea here is that you have many languages that are left behind, you know, in spite of Facebook saying no language left behind. I think most languages continue to be left behind. I mean, if you are aware of the Facebook paper that goes by that title. Anyways, so I think one of these languages is a Coptic language. And, you know, as technology becomes very relevant to our lives, I mean, technology is deployed as we speak in education, in health, in other domains. And as people start to use the technology as it is deployed, there are very consequential things that happen. If I deliver technology for your own language, but not for somebody else's language, you know, I'm definitely depriving these other people from so many benefits. Let's say, for example, from good education that uses this type of technology, which will end up meaning these people will not have equivalently good jobs and so on. And so you're sort of biased and also doing things in society that are not good. So this is very in a very you know, quick statement. This is why we need to think and focus on very low resource languages and kind of like get the technology out there. So this is an example case of why we are doing this particular type of work. Lots of things that I'm going to talk to you about. This is moving so fast. Okay, so Coptic is a liturgical language with, you know, an estimated 10 million speakers. There aren't really many digital resources available for Coptic. As you can see highlighted here, this is like Egypt, you know, some parts in Libya, the Sudan, where there's a little bit of a concentration of that language. It actually, so it continues to be spoken, but on smaller circles. It's also written. So there are some written resources for Coptic, but, you know, not really as much as you would want to. So it's extremely low resource, and also the orthography, you know, is potentially missing in many of the LLMs that exist today. I think these slides, if I were to work on them more, I would change certain things. So I wouldn't say Coptic characters, I would say, you know, something else. But anyways, so the idea here is that the script, you know, is a challenge. So as you work with a new language, maybe the script of that language is not even in the LLM that you would want to work with. So here are a couple examples from Coptic to English text. I can't read Coptic, sorry, but I can read English. There is implanted in a holy man the earnest desire to learn. I mean, there is like Coptic English, you know, because there is a translation of the Bible, for example, you know, into English, and also between English, between Coptic and Arabic. وعيسو يعقوب بارك إسحاق بإيمان. I thought that Isu was a mistake, but it's actually, my student said it's just like this. You know, yes, and Rami can. Yeah, okay. So I actually don't need to talk about motivation. I already did, but, you know, there are some research questions. You know, these are some questions, you know, what is the best methods for training machine translation models for Coptic, English, Arabic involved, you know, in whatever direction, you know, how these models behave on Coptic centered or centric machine translation. Can these large language models, you know, in their own vocabulary be used for that task? You know, how effective is things like zero shot or few shot for Coptic translation? There is some background work here, as I'm not going to talk about, but, you know, there are transformers, MT5, for example, MT to M100. These are pre-trained language models. The transformer, of course, is just an architecture. And there is a little bit of work on African machine translation. In fact, we had a paper, we're doing a lot of other work actually in African machine translation. So check out a paper that we have in ACL this year for a model called TOCAN, where we do 150 pairs of African machine translation, rendering a state-of-the-art on this with about 10 blue points better than Facebook's No Language Left Behind. But okay, so there is some work here. It's not cited in the slides, but because it's very new. There is also kind of, you can do zero shot, for example, using things like Llama with its different versions, Claude, GPT-4, Gemini, or maybe other models. So very quickly, there is some setup here, some data sets that use Coptic English, Coptic Arabic. You can go to the two directions if you wanted to. You can build a model that is dedicated for one of the directions or the other. Or you can also build a many-to-many model, go from any language to any language if you wanted to. And we have that size of data in our data set. The setup here, this may be a little bit confusing, sorry, but there is few, full fine-tuning and there is a few shot. And the full fine-tuning, you have a sequence-to-sequence model under two conditions of tokenization. And then you also use MT5 and M2M100 for that. That's, training here just means full fine-tuning. And then the few shot is done on a bunch of LLMs, okay? And this is another visualization of whatever this is. And this is a description of it as well. And then I'm just going to go to, the zero shot and the few shot. Zero shot, you don't need anything. Take any of these models, just give it some test sets, evaluate. Few shot, just pick some samples from your training data, show it to the model, and then do that your business. And these are the bunch of LLMs used here. You've already seen a pictorial visualization of them. So I'm not going to talk about this again, but here's a table with some results. I think I'm just trying to get to this slide because, the rest is just detail that maybe is not very important, and you already got the idea. So baseline and transformers are both baselines where you train, just fully from scratch transformer model with some particular architecture with your training data, then evaluate on your test data. Or you fine-tune these other models, MT5, Arabic to Coptic, English to Coptic, or a many-to-many, And you could also do Coptic to Arabic, Coptic to English, but we didn't do that for whatever reason. I think the idea here is that, okay, MT5, English to Coptic, English to English, MT5 that involves English and Coptic for that particular setting, it's actually giving us good results. We do both. That's blue. Yeah. It's very small, very low performance. And one of the limitations of our work before Nizar starts talking about it is that, by now, but by now there is half a dozen evaluation metrics that you can actually, and I think Khadija was talking today about the legal domain, right? And you had even another metric. I had a question about this, but maybe I'll ask it in the, you can do blue. Blue is not a perfect metric, but the other metrics in the neighborhood also are not perfect for whatever reason. I teach machine translation, so I kind of know a little bit about this as well. So MT5 does reasonable. I think the thing that I want to abstract over from all the slides is that Claude is a very, very good model for this particular task. And I don't know if this is the case because the data has been leaked to it or there is some other reason. Okay, so if there is one thing that I'm coming out of this paper learning is that, okay, there's something off here compared to, why is it like 83 versus in the 5-shot case versus, I don't know, Google's model is 52, for example, or like 39. Yeah. it's a very good model in many other tasks, as you probably already know. I'm basically done. So yeah, in time.
Very cool.
Yeah.
Great. Thank you.
I actually have 3 minutes for answering questions, which
Yeah,
is
maybe
amazing.
one question in less than a minute.
Hi, I'm Somiagawa. I have been working with Coptic scriptoriums for very many times,
Yeah.
and I got PhD in Coptic study actually. But
Amazing.
I'm so interested in your work. Yeah, it seems.
Thank you for coming.
Yeah, thank you so much. And for Crow3, we found that the Crow3 uses the Coptic scriptoriums data, including private repository in GitHub too. So that's why Crow3 is very good at the zero shot and few shot machine translation, I think. And these days, there's a new translation app called Coptic Translator made by William Ennis and Maxim Wellis and also Andrew Megala from the Williams College. So have you ever also compared that with these models? And how did you manage with the dialectal differences like Bohairic and Sahidic, for example? Because Coptic these days, Copts are using Bohairic dialect for liturgical text, but mostly Coptic scriptoriums data is Sahidic, but recently they add Bohairic too.
Yeah.
To be few.
Yeah, thank you very much again. It's a great question, a great cluster of questions, I would say, and notes and comments and so on. So the answer to your question is that we didn't do any of this in this paper. You know, I mean, there's a lot to do, but I would point you to some of our other papers that exist on this space on a lot of African languages. You know, go to any of the 30+ pages in the appendix to read about, you know, the Coptic script and all the language families in Africa and so on. So we talk a lot about many of these things. And I think it's very important when we do any of these works to care about, you know, variations like, for example, you said dialectal variations and so on. So there is more work to be done on the Coptic-centered machine translation, for sure. Yeah.
Great. Thank you. So this concludes our session.
Come to the posters as well, please.
No. Next is the invited talk. So you had put it up already, right?
I don't know.
Okay. So while Kareem is getting his talk set up, so we're at the invited talk session. It's my pleasure to have my good friend and colleague from almost 25 years, actually, when we first met at the University of Maryland, Kareem Darwish, to talk to us about some of the work that he's doing on benchmarking Arabic LLMs. So Kareem is currently a principal scientist at QCRI and Explain, and he's been doing a lot of work. His biography that's listed on our page is actually really underestimating the amount of work that he has done in his career so far, because so much of the stuff that when I knew him when we were younger, like 5 years old, basically working in the field, you know, yeah, still young, Habibi. So, you know, he hasn't talked about, but recently his focus has been on large language models, human in the loop training for machine learning, and some of the other fantastic stuff that he's working on. So please give Kareem a warm welcome. Thank you.
I'm trying. The 3 dots, I went there, download. So you can see that I'm technologically challenged. The camera I left with when I didn't find you, I left it. Hopefully Control L works. Yes, fantastic. Okay, so thank you for the kind introduction, yeah, Nizar. And funny story is that Nizar, Mona, and I all graduated from the same research group in the same semester. So we must have left a huge void at Maryland, but that's a side point. And actually, my affiliation, I'm primarily now with QCRI, and I continue to be affiliated with Explain. And the talk today is highly tied to the 2 previous presentations, actually in just immediately previous session about evaluation. So I'm going to be talking about BELSAM, which is benchmarking Arabic LLM standards and metrics. And I think, I mean, even though this probably does not need much motivation why we want to do benchmarking, but I'll show you some aspects of LLMs and how they behave that you may or may not have thought about. Like, for example, and I'm sorry if I'm going to go through quite a bit of examples. I know it's not good to have lots of text on slides, so I apologize for that and ahead of time. So the first example here, what are the most important meats to put on eggs? And this is Llama 3.178 billion. I'm sorry, I put 7, but it's actually 8. It actually lists pork as one of them. So that's culturally inappropriate. And then the next example is, who's the author? ودع هريرة إن الركب مرتحل وهل تطيق فراقا أيها الرجل? And you can look at the answer, and it's wrong on so many different levels. It's attributed to the wrong person. And, and the event doesn't even exist. And Hurayra is the wrong one as the target, okay? So this is really, really problematic. I asked her to give me a joke about, cats in Arabic. And it's not a joke. It's sad. It has no meaning. I couldn't get it, no matter how much I tried. Huh? Well, you're laughing at how bad it is, right? Okay. And then one place where it did actually well was, unfortunately, I'm sorry about the text, that how not so pleasant it is. It was basically about summarization. I asked it to summarize a piece of text. The piece of text is much, much longer, but it was actually able to produce a summary that's actually almost perfect. Okay, so it's able to do some certain things quite well. I asked it to do something related to what I think Ahmed Shanqiti was talking about story generation. I asked it to do a story generation of a boy that was lost in the desert for 3 days and what he did during that time. The story is kind of okay-ish, but really not great. Okay. So there's some room for improvement, but it's not dead on arrival, which is great. Okay. More humorous examples. Sorry. Which Sahabi, which companion of the Prophet died in a car accident? It actually didn't answer in Arabic. It gave me an English answer, and it's absolutely insane. And the person died in 1972. And the last example, hopefully this should be the last, is an example of actual things that actually people may actually ask the LLM. Like, for example, I am, 16 years old, I'm 170 centimeters tall, and I heard that gym would make me shorter or stunt my growth. This is, by the way, this is an actual question that I got from Reddit. So this is not a hypothetical question, right? And the answer is completely unrelated to the question. Okay. So the moral of the story is there's lots of room to grow and to improve for LLMs across many, many different aspects. I tried to keep the examples as varied and as different as possible. Some of them are cultural, some of them are historical, some of them are test-based, and so on and so forth. And if we look at why LLMs in Arabic are not doing as well as they would be doing in English, there are plenty of reasons that I think all of us are kind of aware of. For example, the amount of data, Arabic data that exists, is tiny compared to what's available in English. Like, for example, English Wikipedia is 5 times the Wikipedia in Arabic. If you look at the available web dumps for both Arabic and English, Llama 3.1 was pre-trained on about 15 trillion words. And people who are working in the LLM space, they're trying to, fine tune or pre-train an LLM. They'll tell you, like getting 200 or 300 billion Arabic words is kind of tough, right? Let alone getting to 1 trillion or more. So there's a 50 times difference as far as the size is concerned. Also, the data quality in English is considerably. Is the screen shared, by the way? Maybe I should have asked this earlier. It is shared? Okay. We're not actually on, are we on? Okay. So I just wanted to make sure, are we sure? Okay, fantastic. I'm good. So we're good. Okay, this okay, good. Better quality on English compared to Arabic. There's lots of fine-tuning data that you actually can get on the English side compared to English. I'm sorry, and compared to Arabic. There are no universally agreed upon benchmark. That's it. Okay. So data contamination is a big deal. So for example, as we are actually delivering or actually creating data, we're actually keeping the data. Every site can only see their own data because they are the ones contributing it. And the test data is going to stay hidden indefinitely. So there's no, there's no prospect on releasing that data, because we would like to see have the data being double blind for people who are actually coming into the fold. Okay, so we have a def set that's going to be public that people can actually test on and see how the data looks like, but the test set is going to be always private. Okay, so these are the sites that are actually contributing to Balsam. Let me hide this. Okay, you can see quite a bit of organizations already there. And we're always welcoming new organizations to actually join us. Like, for example, having people who are actually contributing to the Arab, to the legal domain actually would be important for us to actually incorporate in what we are doing. As of now, I thought I had the metric, the number of yes, okay. So we're agreeing on a common benchmark data set. We're agreeing on common metrics and evaluation strategies. And we're actually developing, or actually we're almost finished with developing an evaluation data platform where you can actually submit and say, I want to evaluate my LLM. And when you evaluate your LLM, you actually supply an API endpoint where you can actually, we just run everything and then give you back the results. One part, and this is kind of one of the drawbacks of not having your slides in front of you, that sometimes you forget stuff. And I think it kind of goes without saying, is that benchmarking is so important that you actually realize where you're falling behind. And once you realize where you're falling behind, then you can figure out what you need to do to actually improve things, right? So, and the saying goes, if you cannot measure it, you cannot improve it, okay? And this is kind of quite apparent from what we are actually seeing on the English leaderboards. Like, these are the results for English, and you can see over time the LLMs have been getting better and better and better and better over time. So hopefully we'll start seeing the same perspective as far as Arabic is concerned using Balsam. Okay. So in all, we have about 1,400 data sets, and these are not huge data sets. Sometimes they're like 10 examples for testing. Oh yeah. You don't like my face, yeah? Okay, sorry, kidding. So and some of these data sets are relatively small, so we'd have maybe 10 dev, 10 test, and some of them are considerably larger depending on the need for them. But in general, they're generally small. We're trying to cap them to about 100 test examples per data set. And so we have about 17,000 dev examples, 40,000 test examples, a little more. They cover 67 different tests. I just, the interest of, you don't actually have to, I mean, there's too many here. So summarization, question answering, transliteration, sense detection. So there's lots of stuff that we are trying to measure. And funny enough, this list needs to grow considerably. And I'll tell you why just shortly a little bit. Okay. Okay, so if we look at the ways that people have been contributing data, we have three main approaches that people have been following. The first one, and this is the most, probably the easiest, closest, fruit that we can actually grab, low-hanging fruit, is that we use existing monolingual data sets and then we prompt them. So if you're familiar with, I think it's Ginga or Jinja, Jinja 2, yeah. This is the format where you actually say, okay, you just put in your prompt, and then you put in the input and you put the output, and then you get an output on the other side. So for example, this is a named entity recognition example. And typically we have been encouraging people who are actually engaged in this type of prompt creation, is that they don't settle for one type of prompt, because we can ask a question in 10 different ways. So we tell them, do at least 3 up to 10, different prompts per data set. Okay. The other way is doing translation. So a considerable number of data sets that we have, probably in the order of hundreds, were actually translated from English into Arabic. The main culprits were things from prompt source and supernatural instructions. And there was manual checking that was done after translation to make sure that the translation is reasonable. And then often cases when, for example, with supernatural instruction, when the data was actually translated, the instructions themselves were manually verified to make sure that you're getting something reasonable on the Arabic side. This is a couple of examples that you can actually look at. Okay. Actually, I'm sorry. So this is this is an example actually for the templates using Jinja, and this is an example from Belsam using translation. Okay. There's another example from using translation from Hela Swag. Also, the translation is fairly reasonable if you read it in Arabic. Okay. I know it's weird, right? So this actually brings, I mean, this brings to the fore other questions relating to perhaps, cultural sensitivity, cultural, norms and so forth. It might be okay, but it just may sound actually weird because of the context in the target language. So, trimming trees is okay for certain countries, but not in others. I mean, they're just not a common activity that people partake in. Exactly, that's the point. I mean, the example is fine. I mean, it's not a bad example, but you might be actually doing another activity that as opposed to trimming trees. Okay. And the third way that people have been creating data sets, and this is particularly coming from SEDAIA, KSAA, which is the King Salman Arabic Academy, and also from MBZ University of AI, is that they're actually creating data sets that they've actually acquired using, for example, from Ministry of Education, or they're actually creating their own data sets kind of from scratch. And most of these data sets would actually go in to be standard data sets that people can just measure on, like Arabic MMLU and so on and so forth. Which brings to, if you looked at this kind of example, you're asking, this is a yes or no answer. So this is kind of multiple choice. This is not a multiple choice. This is a free form answer that you'll actually have to give. These are also kind of, you can use them, you can actually pair them to be multiple choice or not multiple choice. They could be, and depending on whether you treat them as multiple choice or not, then the metrics will actually change. Yes, thank you. So basically, one of the things that you will notice in most actually, evaluations that are being carried out is that they're being carried out on multiple choice questions, which is kind of problematic because this is not the typical scenario that people actually use the LLMs in. But people do this out of convenience because, you can just get the log likelihoods and figure out what the answer is going to be, okay? So these are kind of questions relating to data and evaluation that we have to worry about. As I told you before, Balsam is not just about having, just data sets, but also, we have a team that's actually built an evaluation platform using LM Harness and Helm as a leaderboard. Also, it's a community where people are sharing not just also data, but actually sharing expertise. I know some of you have attended our meetings, and there's a free flow of how do we solve this problem? Can we do it that way? How about that way? So it's very educational, particularly for people in their early career. Okay. There are some challenges that we have to worry about, particularly about data, reliability and quality. And this is something where we have been going back and forth with the sites that are producing the data, and also who pays for the evaluation. As of now, the King Salman Arab Academy have gracefully, volunteered that they're going to pay for just some of it for now. And also how to evaluate things that without using log likelihoods. So this is, again, going beyond MCQ. There are other problems that we have not touched on that don't exist in Balsam at this point in time, like cultural sensitivity, which was the example that had pork. Also biases, like the one, if you've listened to the paper about, going to prayer after beer. I'm sorry, going to beer after prayer by Tariq. So yes, it's weird. All issues of safety, dialogue generation, and most of the test sets, you would actually want, like, one of the more important capabilities, if you've looked at the Llama 3.1 paper, is that they've gone the extra mile to train on lots of dialogues. So these dialogues don't exist at this point in time, or people are trying to create them, and testing on them is actually important. Also, religious health and things, QA and hallucination detection are all important issues that we need to worry about. Future directions. We're actually looking for people to contribute to Balsam and to join the consortium. We're also looking at how to do human evaluation and LLM-based evaluation. Basically, looking at automated methods for evaluation, and also to collaborate with people who have been working on this for quite a bit of time. Like, for example, the Dolphin data set from Mohammed Abdel Magid, or the ALU data set, data that was created by Mawdu, and yes, and a collaboration with other sites also, and also other, like leaderboards like the one that already exists on Hugging Face. So with this, the last thing I want to do is actually thank people who have worked behind the scenes, that you have worked tirelessly. Rawan, who's unfortunately not here. Abdurrahman al-Sheikh is not here. Actually, most of the people on this list are not here, but these people have been working tirelessly, spending lots and lots of hours to make sure that the code is done right and the data is right and so forth. I think Munira is here, so kudos to her. And that's it. Thank you.
So great effort, Karim, inshallah. You said the data will not be, no one will see the data.
Yes.
So do you plan to host the models and run the evaluation, or you will send the test set without the ground truth to the people?
Okay, so that's a good question. So the way that we're looking to do it is that we have two modes of operation at this point. The first mode is that the site actually has an OpenAI compliant API that we can actually call. So that's one way to do it. They will get the test question, and you would have to, you'll have to tell them, please don't log it, so they don't actually have, becomes a problem. And the other way is that we have an agreement with the Explain, where they would actually host the model itself, so we can make sure that it doesn't get leaked.
Okay. So be careful with the first one, because if you will take the first approach, the data has already been leaked. And my experience here, I like to quote Phil Woodland. They said, if you evaluate your system on the data, even if I'm honest researcher, I don't log, I know that I get 60% in performance on this. So this, you cannot use it as any future benchmarking, because I know how my system is behaving on this data.
Okay.
So unless you plan not to share anything at all, the data has been shared. I mean, let's agree on this in the present, but
okay.
Nevertheless, it's a great. Thank you.
Hamdi, I don't know, I don't know how much time do we have, but keep it very brief, because there's lots of people who have questions.
Yeah. Thank you, Karim. So actually, at QSRI, we participated in many of these tasks,
yes,
like offensive language, hate speech, diacritization, etc. But normally we share this data before, like in our shared task, we share the training data, data and test data. And in Balsam, we participated with all of them.
No,
so that
you participated with about 100 examples per data.
Okay, but I mean the whole test data is already shared before in previous tasks.
Sure.
How do we solve this problem? And this is common in many tasks.
Yes, this is a problem that we have to work through as a community. Yes, definitely. In the back, if you don't mind, I'll give precedence to the people who are younger.
Thank you. So my question is that it's also about
It's also about basically the anonymity basically of the test set. So like we always say that we need to look at the data basically. For example, like will you be providing information about the data? For example, is it
that
gonna
will
be,
give you a diff set that you can look at.
but if I have the def set, like I'm just if I'm a person, if I have a def set, won't I be able to basically look up where it was from and then find the test?
I guess you can.
So okay, I feel like that kind of breaks the entire point. Like I'm concerned about how actually protect like how the integrity of the idea. But
sure, I mean, is the last question about also data? Okay, so this is an issue that we are very cognizant of, and we've had in meetings we're going back and forth, right? And I think ultimately what you would want to do is start generating test sets that no one has seen before, really. I mean, they are either from scratch, or they come from a source that doesn't exist on the internet anywhere, and basically over time that you would actually push away things that people might have seen before. Yes.
My question is more about like how can we actually like use like LLM as evaluator for Arabic, because there are multiple different LLMs and not all of them are as good on Arabic. So what do you think about that? Is that a actual good solution to instead of using MCQs?
That's actually a great question. And mind you, I think I even asked that specific questions to one of the previous speakers. So I'm kind of getting a taste of my own medicine. So this is something that we have not settled completely on, and we're still grappling with. At this point in time, our goal for September 1st is that we close the data completely, do all the rounds of cleanliness and sanity checks and so forth, and we run the first evaluation, and then most of these things will probably go to phase 2. Mustafa?
Yeah.
Yes.
So my question is the type of questions. So for example, you showed an example of named entity recognition. Are we going like to convert existing data sets into the form of instructions?
That's
or I'm missing something.
You're not missing anything. So this is a lot of people actually in the consortium did that.
Just converting existing data sets into like Masadir, take all data sets and convert it.
They've done this with their data sets. That's correct.
Okay.
NYU did it. Explain did it. I think QCRI did that too. So, and are we done?
I think we're done.
The company name is Explain. Do you do any explainability there?
No.
Ooh, very nice. Very nice. Ouch. Where's Hassan when you need it? Oh, yeah. All right. So thank you, everybody. Thank you, Kareem. Let's give him one round. All right. So this next part should be a bit of fun. Leads of the for the posters, please, if you can come up so we can, because we need to go through them. So.
Yes. Did I distract you? I don't need slides.
Do you want to go ahead? Go without it.
Yeah. Okay, so I will very quickly talk to you about the NADI share task, if I get your attention. Okay, so the NADI share task, so NADI stands for Newest Arabic Dialect Identification. It's a misnomer because we not only do Arabic ID, but we also do other tasks related to Arabic dialects. This shared task has been running for several years. We started in 2020. At that time, it was Nizar, Hoda, myself, Abdurrahim al-Madani is a postdoc in my group, and Chi Jiang, who's a PhD student in my group, who just graduated, is going to Facebook next month. This year, we are also joined by Amr, who's sitting there. If you can raise, if you're happy and you know it, raise your hand. I think Walid is sitting somewhere. Yes, there. And Hoda, who is not here. Anyways, very quickly. So this year we did, we had like 3 subtasks: dialect identification, where we did a multi-label, country-level, closed track subtask. We also did the level of dialectness. This is inspired by work that Amr has been doing with Walid. And then we also had machine translation of Arabic dialects. So, I mean, we continue to work in this space, and we would like to continue that effort as well in the future. I won't bore you with a lot of details, but I think what I will say, okay, so the shared task, you know, I feel it has been very successful. We got 50 plus teams registering, lots of people, you know, did a lot of valid entries, like 76 valid entries into, you know, the systems, the leaderboard. And then we ended up with 10 submissions for subtask 1, 7 for subtask 2, and 16 for subtask 3. And I think, you know, we gave people data. We also have seen people do a lot of innovative and interesting approaches to solve the problem. And I think I'm running out of time, right? Yeah. I just want to congratulate people who have won in the shared task. Omar, I think you were one of these people. I just want to give you, yeah. And yeah, so thank you very much for your support. And I now give the mic to Mustafa Jarrar.
Thank you.
Thank you, Muhammad. Thank you, Nizar. So, the first Arabic financial NLP shared task, so it's about finance. So we are a group. Actually, I'm presenting on behalf of Mahmoud Al-Hajj, who is supposed to be here, but he's the leader of the shared task. So I'm just a participant. And the tasks have two subtasks. So intent detection. So we give you the question in a dialect, and you just detect which intent in the banking domain. So the intents are 77. So we just classify sentences basically, but we have multiple languages. We have a huge data set. So same questions in MSA, in Palestinian, in Saudi, in Moroccan, and in Tunisian. The majority are Palestinian and MSA. We have another subtasks, which is to translate an intent sentence, but we don't evaluate the translation. We just say, did you like preserve the intent or not? Is it like the same classification or not? It's very interesting and nice thing actually. And so we get so 11 teams participated in the first subtask and 1 team in the last subtask. So MA, I don't know what's MA, by the way, I forget maybe if somebody is here, no, the name of the team. So, yeah, nobody is here, yeah? Okay, so, and we will present it in the posters, so you can come and see.
Thank you very much. All right. Next.
Hello, everyone. I am Nagam Hamad, a PhD student at BERT University. This year we participate with وجود near 2024 shared task, which is the second Arabic named entity recognition shared task. It's a collaborative work between Sina Lab, Dr. Mustafa, me, and Dr. Muhammad, and also with UBC Lab, Dr. Muhammad Abdel Majid, and Abdurrahman Madi, and Bashar Talafha. So in this year, we focus on fine-grained Arabic named entity recognition. As we know, named entity recognition is a challenging task, and most of the previous work focus on flat named entity recognition and coarse-grained. So we make this task more challenging in order to encourage participants to participate in this shared task. We have 3 subtasks. The first subtask and the second subtask are closed subtasks, focus on fine-grained named entity recognition and use the وجود fine-grained dataset. The third subtask is an open track subtask using another dataset, which is وجود Gaza. For the وجود fine, it contains about 550,000 tokens annotated with 51 entity types and subtypes, while وجود Gaza contains about 60,000 annotated also tokens with entity types and subtypes. In this shared task, only 5 teams participated. 5 of them submitted to the flat, 2 of them submitted to the nested, while 1 of these teams submitted to the third subtask. Okay, for the results, as we can see here, the results variance slightly from the baseline. I wanted to thank all of the participants that is participate in the subtask. We can, I don't know, Musi, it's not here, but I will thank Dr. Sakhar, Munira. They took the second place in this task, and also thank for Dr. Fadi. Yes, Dr. Fadi and his team also, that they are participated in the 3 subtasks. Yeah, in the 3 subtasks. So we know وجود is limited to the specific domains and dialects, and we hope in the next subtasks that will must or will contain more domains and the dialects. Thank you.
Hello, everyone. I'm address diction configuration. The shared task contains 2 subtasks. The first one is the reverse dictionary, the Arabic reverse dictionary, and the second one is word sense disambiguation. For the data set, the RD task contains almost 39 entries. For the WSD task, it almost contains 28 entry with a dictionary that contain 15 entries. For the participant team, almost we have 46 team. For the final submission, 5 team have submit to the RD task and only 1 team submit to the WSD task. For the winner, the best team was USUS team. They are here. Umar and Dr. Abdullah. The second team was Baligh, and the last team was Mission team. For the WSD task, the task was excluded because the participant team have achieved a result of almost 64% lower than the baseline approach. Thank you.
Hello, I'm Ala El Jabari, one of the co-organizers for the Arabic NLU 2024 Share Task, which is the first Arabic natural language understanding share task. It's focused on pushing the boundaries of the Arabic natural language understanding through two challenging subtasks, which is the word sense disambiguation and the location mention disambiguation. For the word sense disambiguation, it aims to select the correct meaning of ambiguous words based on the context. For this subtask, we provided the participants with the Salma corpus, which consists of about 1,440 sentences. While for the location mention disambiguation, the subtask focus on accurately identifying a location mentioned within a microplugs and connect them to a specific toponym within geographical positioning databases. And for this subtask, we provided the participants with the AREEj data set, which consists of about 2,800 posts. We have 38 teams registered, but out of them, 3 managed to submit their systems, 3 for the WST subtask and 2 for the LMD subtask. For the results, for the WST, the highest performance was 77.8%, and none of the participants outperformed the baseline, while for the LMD, the highest was 95%, and all of them outperformed the subtask. I don't know if any one of them is here, and thank for them. Thank you.
Thank you very much. Are there any others? I mean, I'm gonna do the last one. If no, okay. Because we have 8, but I've only counted 5 so far, so I'll be number 6. I know some people couldn't be here in person to do it, so Hamdi, did you don't? Okay, very good, no problem. All right, so I'll present the last poster. How do I do this in full screen? Control L. Even okay, never mind. Sorry. Okay, I guess we can let him present online. This is last minute. Is he? I downloaded. Okay.
Okay, once it's downloaded, yes. Then you do, I think, Control L.
Okay, thank you. All right, I'm going to do the fig news one, and then apparently we have a 7th one that will be done online, so we're going to get a Zoom presentation on this. So I was one of the co-organizers of the Framing Israel War in Gaza Shared Task, or Fig News 2024, and this was done with my colleagues, which is Aghwani, Mustafa Jarrar, Huda Ba'amar, Imad Zitouni, Mana Diab, Samha Al-Biltagi, and Mohammed Bouada, who is one of my assistants in NYU Abu Dhabi. So this is kind of a different kind of a shared task. So whereas in most other typical shared tasks, we give you the data with the labels and we let you go come up with techniques, machine learning solutions, or whatever clever solutions you come up with. In this task, our goal is to actually, we don't know the answers. We want you to help us develop the answers. And particularly with tasks that are kind of very highly subjective in nature, like bias detection and propaganda detection, we found that this would be kind of an interesting way to even, address a topic as hot as the topic that we selected for this. What we had done to kind of unify the effort, so the shared part is about 15,000 posts that were all taken from approved account owners on Facebook. So we had access to get that data, especially in Arabic, English, French, Hebrew, and Hindi. And they were all done with very simple keyword search. So it was actually the word Gaza, I think that was the word that is used basically in different scripts to get these data points. The idea then, we gave the data to everybody. We organize it. I can talk more about this also at the poster session. So come by, stop by, talk to me. And we asked people to come up with a set of guidelines for defining bias and for defining propaganda. We specified the label categories in general, but we did not get into the details. And then you could say, well, how can you evaluate then? Like, so what is the evaluation? So we had to come up with clever ways, to say, how do we evaluate the quality of a guideline? Well, it's through things like inter-annotator agreement, through coverage of what do we expect at a meta level good guidelines should have in it, and also just the amount of data that's being generated. So in total, we had 17 teams, 16 were biased toward biases, people are biased toward bias, and then 6 in God, okay, it's a joke. And 6 propaganda. Okay, it's not my day. And almost 130,000 data points were created, which we think will be encouraging the community to work. So I'm just gonna, I put the names of all of the winners. There were 4 tracks to participate in. One is a qualitative track of the quality of your guidelines, IAA or inter-annotator agreement quality, simple quantity, and then this new concept we're calling consistency, which is really more like the centrality of your team's annotations vis-a-vis other teams. So if everybody agrees with you more than they agree with anybody else, you're probably doing something right. It's an assumption. So NLP collab, I put in only the names here, one, many. I believe this group had a huge troop of annotators that I think there were 20 annotators that all worked together and competed, and they did quite well across everything. But everybody is a winner for helping us produce this. So come and check out the poster. Thank you very much. Now, is it Firoz?
Yeah, I think Maram will present.
Yeah.
Okay. Firoz, should I just share? Do you want to share your own slides? We let you share, or should I put up the slides for you?
Yeah, Maram will share the screen.
Yeah, I can, but you need to allow me to do that.
Okay, so
Or
how do I
stop sharing?
stop sharing? Can you share now?
Let me try. Yeah, I can.
Okay, fantastic.
Okay, so hi, so I'm Maram Hassanein, a postdoc at QCRI, and this year we organized the 2nd edition of the Arrival Shared Task on propaganda detection on Arabic content, with the help, of course, of this great team from multiple institutes at Qatar and Canada. Our shared task covers 2 tasks. So task 1 is on the text modality. So given a multi-genre text, the systems are required to predict propaganda techniques used in the text, and of course, identify the text spans where these propaganda techniques are being used. In the second task, we look at multimodal content, and specifically we look at memes as an example of such multimodal content where we have images and a text overlay. And the task here is modeled as a binary task, so the systems are required to predict which of these memes are propagandistic and which are not. For task 1, we collected a large set of around 10,000 manually annotated text snippets. So our sources of data are tweets. So we collect tweets from news sources. And also we give focus to the tweets on the current war on Gaza. For the second type of text we look at news paragraphs collected again from a huge set of news articles. Of course, as I said, we manually annotate these. For task 2, we collected memes from public groups on social media platforms like Facebook, X, and Instagram. We extract text from these images using OCR. For dataset, we annotated 3,000 memes as well. And eventually, I think we had a successful kind of run of this year. So we had a total of 14 teams participating, with 6 teams participating in task 1 and 9 teams participating in task 2. I leave further details for you. I hope that you can be intrigued to look at our poster online and also look at our overview paper to know the winning teams and also the techniques that they tried. And we thank, of course, our funding agencies from Qatar. And of course, if you need more details on our shared task, this is the website you can look at. I hope I made this quick. Thank you so much for your time.
Here. Okay, so it's coffee time for people who are here in person, and then we all go to the poster session. So effectively, we're not coming back. So this is a semi-adjournment. Thank you, everybody, for every way you participated in making this event a success in my eyes. And as I said before, this is running on volunteers. Let me know if you're interested in helping in the next edition or in SIGARAB in general. And again, thank you very much and have good travel back home. Thanks.